Uh, so let's first do the paper on computer network. We have finished the syllabus. Okay. So we are going to do the 2024 MCQ and uh, the structured essay paper. Okay. Right. So let's first do the MCQ paper. Uh, Basically, the MCQ paper is relatively easy, uh, whereas uh, structured paper is it's actually not difficult. You get two questions, so therefore, if you have studied that area, mastered that area, you can easily get the marks. But if you have paid less attention to that area, right, because we don't know from which area the examiner is going to ask questions. Maybe he's more interested in error correction, subnetting, okay, so virtual VLANs. So therefore, there's a big risk when it comes second paper. So therefore, yes, you need to master each and every topic, but at the same time, try to get the maximum from your MCQ paper. So that is how you reduce the risk. And the good thing is last year, MCQ paper is only one answer correct. So that also make it relatively easy. Okay, right? Only one correct answer. Right. So let's go to do the MCQs. Right. The International Organization for Standardization, ISO, proposed a fundamental reference model for network communication. Which of the following options identifies this model? So remember, we have three models. ISO has proposed the OSI architecture, 7-layer architecture. Then your book or your reference book use another architecture. Then we have the internet architecture, 4-layer architecture. Okay. Uh, so what ISO has proposed is OSI architecture, OSI, right? ISO, OSI. So that we have already discussed. Answer is B. That is easy question. B. Okay. And second one. What is the layer responsible for handling physical transmission of data between adjacent network nodes on the same network segment? Okay. In the TCP/IP model. Okay. So they refer to the TCP/IP model or the internet model. So if you just look at the first word, you might think, okay, this is physical layer. Okay, so that is why I highlighted some terms as well. But read on, right, of the data between adjacent network nodes on the same network segments. So within the network segment, it's handled by data link layer. Between network segments handled by network layer. That is why we say network or between subnetworks or networks. When that is why we need router. Router is a layer 3 device. Switches are layer 2 devices. Switches can handle within the same network segment. Routers are for handling internetworking. Okay. So therefore, at the end, every transmission is a physical transmission. But because it says between adjacent network nodes on the same network segments, so it should be more link layer, right? Link layer. It's a little bit confusing because examiner has inserted the word physical transmission, right? But the expected answer should be D. Okay, D. Right, third one. What networking devices facilitate connections between two or more distinct networks? So pay attention to words. Right? Two or more distinct networks. That means different networks. Right? So typically different networks routing is transmissions are handled by routers. Okay. But here you can see the word router is not there. So then you need to find another something closer to that. Okay. Using networking terminology. Obviously it can't be hub. because hub is just broadcasting. So therefore, it's always within the same network. Access point is something like wireless access points where we connect to our devices. So that can't be between distinct port network. That is your network server and client machine or the device. Gateway is a possibility because you can see it can't be firewall. Okay, it can't be modem because modem's task is convert analog to digital and digital to analog. Okay, so therefore, so it has to be gateway, right? So remember, gateway is where we send our traffic outside. That is why we say gate. So the point where our internal traffic is sent outside is called gateway. So usually gateway is a router, right? But the general term is gateway because it says distinct networks. So then it should be a gateway, which is often a router. Okay, because router is not there. The general term is gateway, right? So the answer must be C. Yes, C. Okay. So let's move on to our next question. Question number 4. Which technique allows for the flexible distribution of network bandwidth, right? Flexible distribution of network bandwidth among hosts in response to fluctuating short-term demands. So remember, we have time division multiplexing where fixed time slots are assigned. But that is not optimized because you always get the fixed time slot. Sometimes a particular machine doesn't need that time slot. Okay. But in order to optimize that, we have a better option. What is that? Statistical time division multiplexing. Okay. Statistical time division multiplexing, where the device analyze the statistics, traffic details, and dynamically allocate more time slots to high demand connections, low number of slots to low demand connections. So therefore, that is called what? Statistical time division multiplexing, not normal time division multiplexing. Right? There's nothing called resource division multiplexing. FDM is you allocate frequency bands. Okay, so that is more for the analog transmission. For digital transmission, what we use is time division multiplexing and its variation called statistical time division, not just statistical multiplexing. So the answer is D. We have discussed those things. Okay, we have discussed those on the physical layer. Physical layer. Right? Encoding, modulation, then multiplexing. Okay, so synchronous TDM, asynchronous or statistical TDM. Okay, so allocate time slot dynamically based on demand. Okay, so therefore answer is that. Right, fifth one. The medium access control MAC address. Okay, a sublayer. So MAC is part of the data link layer. So we subdivide the data link layer into two subparts also, right? One subpart is MAC layer. Sublayer plays a crucial role in managing broadcast network issues. In which layer of the reference model proposed by ISO is this sublayer located? So this sublayer is in the data link layer. This sublayer is in the data link layer. So the answer must be D. Right? D. So I think our cover page also has that. You can see this is MAC layer. MAC layer is in the data link layer. Other one is LLC. Okay. Logical link. Okay. Even the title page has it. Right. Sixth question. Given a channel with a data rate of 1 kilobit per second, what is the maximum number of bits that can be transmitted over the channel in 1 second? This is like asking in which month the October revolution happened. නේද? ඔක්තෝබර් විප්ලවය වුණේ මොන මාසෙද කියලා වගේ question එකක් තමයි මේක. මොකද ඒක ප්‍රශ්න දීලා තියෙනවා. So if it is 1 kilobit per second, so that means the maximum number of bits that can transmit is 1 kilobit, right? So there is no formula, nothing. But remember, when it comes to bits, kilo is 1000. When it comes to byte only, kilo is 1024, 2 to the power 10, mega is 2 to the power 20, giga is 2 to the power 30. That is only for byte, right? Bits, hertz, or any other, right? Meter, grams, kilo is 1000. Bits, it's 1000. Okay. So therefore, this is 1000 bits. The maximum that we can transmit is 1000 bits, not 1024 bits. Okay. Maybe just examine and check whether you know that bits it is 1000, for byte it is 1024. I think that is also mentioned in our note. Definitely it should be mentioned somewhere. Usually we discuss in semester 1 too, okay? Yeah, I think it's not mentioned because it's obviously you should know from semester 1 too. Let's see whether it's mentioned there. It's not specifically mentioned, but just remember, so that is common sense, okay? So we discuss in the very semester 1 computer system subject, right? So if you look at semester 1 note, it should be there, okay? And so the next question, seventh one, what is the typical use case or benefits associated with a web browser storing cookies on a user's system? So that is from your semester 2 web development. So cookies, the server can save a piece of data so that when the client machine send a request again, so that cookie data is also sent to the server. So therefore, server can track the user behaviors, client behaviors. So because we can always update the cookie, we can set multiple cookies, right? So which page the user has visited, right? And so on. We can even we can use cookies to handle sessions because otherwise you need to spend a lot of your servers uh, RAM. Okay, right. So it's a very simple question under application layer. Boost internet speed by increasing bandwidth? No. Ensure antivirus protection? No. Track your activities on the web? Yes. Track your means client's activity. Automatically update web browser software? No. Improves the computer's processing speed? No. So the answer is C. Okay, 7C. 8. So you can see you should be able to get maximum out of this. Maybe, right? If 25 questions, at least 22, right? At least 22. So then you are pretty much already you have passed. Okay. So then second paper, you convert that into B's and A's. Right. What is the primary purpose of the twist in twisted pair cables? So why do we twist our twisted pair cables? To reduce uh, induction or radiation, right? One wire signals in one wire influencing the signals in the other wire. So that is the main reason. So that also we have discussed. It's in your note, okay? Under physical layer, uh, under copper wires, okay? So why twisted? Reduce crosstalk. Crosstalk means one wire signals influencing or overlapping with the other wire. Okay, other wire. To improve the flexibility of the cable, no. To enable the cancellation of radiation from one wire to reduce the noise, fairly good answer. Increase the strength of the wire, no. Make cable management easier by preventing tangling, no. Again, පැටලෙන එක වළක්වන්න නෙමෙයි. To enhance the data transmission speed by reducing resistance. Actually, it doesn't increase the resistance. It basically enable the cancellation of radiation from one wire to reduce the noise. Okay, so that is crosstalk. Like B. B. 9. Which of the following frequency ranges fall within ISM bands? ඒක ඉතින් ඔයා කටපාඩම් කරන්න මම එක් කරද්දිත් කිව්වා අහනවා කියලා නිතර අහනවා එක්සැමින. ISM bands උගාට මතක තියෙන්න ඕන මොන මොන bands allocate කරලා තියෙන්නේ කියලා. That is under wireless communication. Okay. Wireless. ඒක අපේ note එකේ තියුණාද නම් මට මතක නැහැ. UCSC note එකක් දැන් බලන්න ඕනේ. දැන් වැඩි බලන්න ඕනේ UCSC note. Our notes are to understand the subject. But exam is set by your UCSC lecturer. Okay. අපේ note එකේ සමහර විට තියෙන්නේ නැති. මේකෙම තියුණාද මතකත් නැහැ.
We do have on the physical layer.
Physical layer, yeah. Should be somewhere. ISM bands. Under wireless. Yeah, so these are the ISM bands. Okay. So it's in the diagram, but not separately mentioned. Okay. So the question is about which of the following frequency range fall within industrial, scientific, and medical band? Industrial, scientific, and physical band. So මේවා තමයි ISM bands, right? So this is 902 to 928, 2.4 gigahertz to 2.4835. So those are ISM bands. There's another band here. Okay. ඒක මතක තියාගන්න එක අසාධාරණ ප්‍රශ්නයක් ඉතින් කරන්න දෙයක් නැහැ. මොකක්ද එක්සැම් එකේ answer එක? C. C කියන්නේ මොකක්ද? 2.4 to 2.4835 එක තියෙනවද? 2.4 to 2.4835. Yeah, so this is one of the band, right? ඒ කියන්නේ එක්සැමිනර් බලාපොරොත්තු වෙනවා මේ කටපාඩම් කරයි කියලා. හරි අසාධාරණයි. හරි මම නම් ඔය ප්‍රශ්නයක් තියන්නේ නැහැ. But that is what the examiner's expectation, okay? So just double check what is this UNIL bands. Okay. So shall we ask because ये बारे करते होते हैं. But this is another ISM band. Okay, let's ask ChatGPT. So this is for industrial purposes. There are some different range. Maybe you can have a small note on that. Okay, so ISM bands involve Wi-Fi, Bluetooth, Zigbee. Okay. So 2.4 range is the Wi-Fi one. Okay. So then what is this other one? UNII, right? Unlicensed National Information Infrastructure. It refers to the frequency bands that are allocated for unlicensed wireless communication, especially high-speed data networks such as Wi-Fi. That is for our normal day-to-day usages without getting license. So our Wi-Fi, but Wi-Fi is here also Wi-Fi, right? Yeah, these then can also be used for Wi-Fi, wireless bridges, and so on. Okay, this is a comparison. ISM versus this originally for industrial, scientific, and medical equipments, originally for wireless networking infrastructure, includes this band, mainly 5 gigahertz bands. Here used in Wi-Fi, Bluetooth, and so on, mainly used for Wi-Fi and broadcast wireless. So that can also be used for Wi-Fi. Okay, and this both anyway, both are license free. Okay, both are license free. Still, I don't understand why there are two things. Okay, maybe later they allocated this range. Okay, so just do a small research. Maybe someone can ask. Okay, right. So that's next question. What is the maximum data rate achievable on 1000 kilohertz noiseless channel using binary signaling schema? So important words are what? Noiseless channel. That means ideal. And binary signaling, right? So if noiseless channel binary signaling, the data rate is twice the bandwidth. Twice the bandwidth. Uh, so therefore this is 1000 kilohertz. Remember hertz, kilo means 1000. Okay, 1000 into 2. So then you get it in bit per second. Or if it is kilohertz, kilobit per second, because kilo is 1000 in both units. So in other words, it is 1000 kilobit, 2000 kilobit per second. 2000 kilobit per second. Okay, 10D is D. So remember the theory part in physical layer. Channel capacity. So noiseless channel, that is where you can get the maximum 2V log 2V. So V is the bandwidth in hertz. V is number of signal levels. So if it is binary signal, so that is usually the case, the V is 2. Then log 2 is 1. So log 2 is 1 means the maximum data rate is 2B, right? 2B. Remember that is for the noiseless. If it is noise channel, that is the practical situation. So we have another formula, right? So that is B log 2 1 plus SON bits per second. So SON is signal to noise ratio. So that they should give. B is again bandwidth. Now it is not 2 times. Okay. So they should give signal to noise ratio as a normal ratio or log scale. Log scale එකක් විදිහට දෙනවා. හරි. Decibel වලින් දෙනවා ගොඩක් අයට 10 log scale එකක් විදිහට. Okay. Right. Right. 11th question. What term is used to describe communication links that allow data transmission in both direction, but only one direction at a time? Only one direction at a time is half duplex. Okay. So that is the next slide. Right. So you can see two-way communication, but one way at a time. That is half duplex. Right. When the spectrum of communication channel is divided into frequency bands, with each user having exclusive access to specific band for transmitting their signal, this technique is known as, that is different users are allocated different frequencies. So that is called frequency division multiplexing. So use of multiple users to use the same band or same channel. One approach is frequency division multiplexing. So other than that, we have the uh, code division multiplexing, CDM, right? We have the time division for digital data, right? Uh, Statistic and asynchronous, okay? Even we have the wavelength division multiplexing that is used by uh, fiber optics, okay? Right, so the answer must be frequency division multiplexing, A. 13. Which of the following statement best describe forward error correction? Forward error correction means what? We send the error correction details with our data. That is called forward. The other one is backward. Backward means we we ask the sender to resend it. Right? So these are error correction, right? Not detection. Remember detection versus correction. Detections are done by using checksums. Corrections, either we send like Hamming codes where we not only detect, we know that where the error is, right? Where the error is, and we can fix it without asking to resend. So that is called forward. Backward means, so that is automatic repeat request. That is where you ask, you detect it, but you can't correct it. So therefore, you ask the sender to send it. Still, we can correct the error, but asking to repeat, right? Right. So it is a technique of forwarding the frame to the next hop without correcting errors. No, it is a method of detect errors at the receiver and inform the sender. No, informing the sender is not forward error correction. So that is automatic repeat request. It refers to including a checksum in the data. Checksum is not enough. Checksum is for detect. So this is correction, right? It refers to the technique of including enough extra information in the frame so that the receiver can correct the error. Yes, receive, the most important word is receiver can correct the error, not asking the sender to resend. So that is why we say forward error correction, right? So that is correct. It corrects error before sending the data. No, there's no such thing, right? So, of course, if you are again sending, you can do it, but this is the perfect answer. Okay. So, forward error correction means without asking the sender to resend, we should be able to, or receiver must be able to correct it using additional codes like Hamming codes. Okay. But the overhead is you need to send additional bits. So error detection also you need to send additional bits like uh, parity bits, but for forward error correction you need to send more and more additional bits. Remember Hamming codes, right? So we need to insert Hamming bits, right, in different uh, places. Okay, so there's a logic we discussed that. Okay, so the answer must be D. D. Right. In an error handling system, R check bits are added to an M bits message before transmission. What is the code rate of the system? This particular formula was not in your our note. I don't, maybe it was in your UCSC note. So I added that and uploaded it again. Okay, I added this and uploaded it again. It's very simple idea, but it was not mentioned explicitly in our note. So remember, uh, in error handling systems, whether error detection or error corrections, if it is, we need to send additional bits. So therefore, it increase the packet size or the transmission. So then what is mean by the code rate of the system? Code rate of the system is the total number of bits you send, right? The number of bits you need to actually send, that is your actual workload divided by total number of bits you are supposed to send. Say you are supposed to send only 1 byte, 8 bits, but in order to do error corrections and error detections or both or one, you need to add some more bits. So say you need to add say two more bits. So then you send 8 bits, set 8 bits, but your actual data is only 8 bits. So then 8 divided by 10 is your code rate. Code rate. So your new note has it. Okay, I added that slide. Okay, uh, and uploaded it. So now this note has. Make sure you download the link layer. Okay, link layer again. Where is that? Right. So if number of information bits is M, that is your actual message bits. And if you need to send additional of R number of check bits, so the additional parity bits and so on. So the code rate is M divided by, that is the actual data, the total bits M plus R. Okay. So therefore answer is M divided by M plus R. Okay. E. E. Right. 15. If the minimum Hamming distance between any two valid code words is given is 5, that is minimum Hamming distance. Right. HD. What is the maximum number of errors that can be detected using this code? Remember, we have two formulas. One formula to calculate maximum number of errors that can be detected. Another formula, maximum number of errors that we can correct. Okay. So, so that is already there in your note. Right. So if your minimum Hamming distance is d min, uh, error detection, that is d min minus 1. Okay. Error correction, the maximum number of error correction is d min minus 1 divided by 2. Okay. So what is d min? That is when you are given the codes, all the possible codes, the maximum number of changes, right? Maximum number of changes. For example, from here to here, 2 bits have changed. From here to here, this 1 has become 0, this 0 has become 1, 2 change. Sometimes there can be 2 bits, 3 bits. So out of those, okay, uh, so you need the minimum value. So that is our d mean. So then when you know the d mean, you know the maximum number of uh, errors you can detect, that is d min minus 1. Correct, that is d min minus 1 divided by 2. Okay. So therefore the answer is, this is not correction, this is asking about detection, that is this 5 minus 1, that is 4. Right. D. D. Okay. 16. Which one of the following statement is correct regarding the parity bits? Remember the odd parity, even parity, or you can have even more complicated parity bits like, so that is error detection, right? Not error correction. So you can have the odd parity or even parity, that is the simplest one. You just add a 1 bit. If it is odd parity, the total must be odd number of ones. If it is even parity, you add 1 or 0 to make it total number of bits as even value. For example, if we use even parity, already we have even number of bits in our data, so therefore the parity bit must be 0. But for the same data, if we use odd parity, now it's even number of ones there, so therefore our parity bit will be 1. So there is no winner saying which one is better. Both are okay. It's just your choice, odd or even. Okay. Uh, right. So that is one approach, but it can only detect single errors, single bit errors. If more than 1 bit has corrupted, no, you can't find using simple even parity or parity. Okay. Only single bit errors. Right. But if you want more sophisticated error detections, there are more approaches like cyclic uh, redundancy checks and so on. Okay, so here you can see it's more complex, more uh, sophisticated checksums. Okay. Right. So then error correction, it's basically done. One approach is Hamming code, but again Hamming code can fix if there's only 1 bit corruption. If it is more than 1 bit corruption, no, you can't fix that using Hamming code. Okay. Right. So we discuss Hamming codes as well. Right. Even parity is better than odd parity. There's no such thing. It's just a convention. Okay. Just we can either use even parity, but we need to agree both sender and receiver. Right? Odd parity can be used only if there's an odd number of bits in the message. No, there's no such thing. Even parity bit can be calculated by taking XOR operation of all the bits in the message. So that is one approach, because we just need to check whether we have, right, even number of bits. That's it. Right? If you have even number of bits, no issue. If you have received odd number of ones, so that means one bit has been uh, corrupted. So we can check using XO, because XO 1 1 is 1, 0 0 is 1. If it is odd, 0 1 1 0, it is 0. Okay. So therefore, yes, we can use that approach. මේක ඔළුවට ආවේ නැත්තම් මේක නෝට් එකේ තියුනේ නැත්තම් ඒත් බය වෙන්න එපා, අනිත් හතරම වැරදි. Right? Odd parity bit is equal to the even parity bit. එහෙම වෙන්නේ නැහැ. If odd parity bit is 1, even parity bit must be 0, because our logic is inverse. Right? Right. So මේ example එකෙන් පේන්නේ නැති odd parity වලට යනකොට 1 දැම්ම නම් even parity වලට යනකොට 0 දාන්නවා. Because, right, so if you go for even parity, parity bit is 0. For the same message, if you go for odd parity, parity bit is 1. Okay. Even parity can be used only if there is a even number of bits. No, there's no such thing. එහෙම බැලුවත් ඔයාලට මේ උත්තරේ guess කරගන්න තිබුණා. හරිද? XO කරන්නේ ඇයි? XO කරද්දී even number of ones තියෙනකොට, ඒ කියන්නේ even number of කියන්නේ 0ත් එක්ක XO එක true කියලා එනවා, නැත්නම් XO එක false කියලා එනවා. 0 1 1 0. Okay. C. 70. What is the primary purpose of checksum in the data transmission? So checksums are added to detect errors, not to correct errors, right? Correct errors, we need something else like Hamming codes and so on. Checksums are to detect errors. Okay. Detect errors. D. D. So parity bit is also checksum. Okay. It's sum. Sum is odd or sum is even. Right. 18. What is the vulnerability period for a frame of similar size of slotted aloha, given that vulnerability period of pure aloha is T? If the vulnerability period of pure aloha is T, what is the vulnerability period of slotted aloha? Remember, slotted aloha is better than pure aloha, right? So that is why we say, because in pure aloha we just send it, but slotted aloha you don't send it through during a transmission. Okay. So therefore, definitely this must be better than slotted aloha must be better than this. Okay. So therefore, it can't be 2T, 1.5T, 3T. It's better, right? Better means it must be lesser than this. So in that sense, it must be T divided by 2. ඒක note එකේ අපේ note එකේ නෑ, ඔයාගේ UCSC note එකේ තියුණාද මතක නෑ. 18. Anyway, answer is B. Obviously, because it should be better. අපේ note එකේ okay වෙන formulas ටිකක් දාලා තියුණා. මම ඔක T/2 කියලා දාලා තියුන්නේ නෑ. හරි. That should be under data link layer. Aloha. මතක නම් ලොකු formula වගේක් තියෙනවා. So this is pure aloha. There's a bigger chance of collision, because in pure aloha, whenever they have data to send, they send it. Okay, they send it. So that means there's a very big chance of collisions, because it doesn't check the traffic. In slotted aloha, device transmit data only at the beginning of the time slot. Right? Only at the beginning of the time slot. So therefore, if a particular uh, device need to send something, it wait until the starting of the time slot. So that facilitate any transmission during the previous time slot to finish. Right? So that increase the probability of or decrease the probability of collision because you just wait for the end of the time slot. Okay, end of the time slot. Uh, now you can see. Uh, so this guy wait for the end of the transmission and then send it. Okay, then send it. Right. මේකේ කොහෙවත් අර 2t කියලා දාලා තියුන්නේ නැහැ. නමුත් මේ වැඩි graph දෙක තමයි දීලා තියුන්නේ. හරි? maximum වලින්. බලන්න ඔයගේ note එකේ තියෙනවද කියලා 2 times කියලා. UCSC note. ඒක තියෙනවද කියලා. ඒකෙන් තමයි අපේ note එක හැදුවේ. නමුත් ඒක miss වුණාද දන්නේ නැහැ මගේ අතින්. 2G කියලා තියෙනවා. Yes, this half the vulnerable period. වෙති. Right. So this half the vulnerable period. So ඔන්න ඔයක තමයි අල්ලලා තියෙන්නේ. හරි. So අපේ note එකට ඒක ඇල්ල දාන්න බැරි වුණා. හරි. Again. Because you don't just send it, you just wait for the end of the time slot. Okay. Right. So make sure you go through the UCSC notes also. Actually, this now it's the time to go through the UCSC notes more than our notes. Okay. Right. 19. Which of the following statements correctly describe the role of management plane in networking? So this is from, I think, the last topic. Okay. Software defined networks. Or the network managements. I think network management, right? No, software defined networks. Yeah, software defined networks. Okay. Different planes are there. Right. Northbound API, southbound API. Right. So data plane, control plane, management plane. So management plane is the higher level plane for management work by the sys administrators. Okay. Network administrators configure and monitor the network using this plane. Okay. So it's for the net management work basically. Okay. Right. So that should be easy question. Manage the active topology of the network. මේක manage කතන්දරයක් තියෙනවා. Sorry, not manage that topology. Enable network administrators to manage and oversee network operations. Sorry, not just the topology, overall management. Okay. So answer must be B. B. 20. Which component of software-defined network allows controller to program network devices at layer 3? මතක නේද? අපි program කරන්නේ northbound එකෙන්ද southbound එකෙන්ද? මට මතක නැහැ කොයි එකද කියලා හරියට. Right. Program forwarding tables is there. Yeah, northbound API is to high-level applications. Southbound API is to manage your flows. Okay. So the question is about controller to program network devices at layer 3. So that should be southbound API, right? Yeah, program the network devices. Very good, Gati. So southbound API. It's southbound API. E. Yes, C. Right. 21. What is the purpose of implementing routing in hardware tables at the network layer? So remember, if you take something to the hardware layer, what happens is it become rigid, but it become more efficient, right? Hardware means efficient but rigid. Software means slower but flexible. ඕක ඕන තැනකට හරියන කතන්දරයක් තමයි. හරි? So therefore the answer is when you usually we prefer to have the flexibility these days. But if you really want the speed over flexibility, give it to the more and more hardware. Hardware means more and more firmware as well. Okay. So the answer is D. Keep the high speed links and route packets at link speed. So if you are interested in speed, because consulting the software routing table is time consuming. Okay. Right. Answer is D. හරි ඒකත් ඔය නෝට් එකේ තියෙන්නේ නැති අනිවාර්යෙන් හරි right 22 what file was used in ARPANET to store computer names and the corresponding IP addresses ඉතින් ඒක ඇවිල්ලා history of networking වලින් අහලා තින්නේ ARPANET එකේ මොකක්ද අහන ෆයිල් එකේ නම මේක කලිනුත් අහලා තිබුණා මට මතක විදියට ඒකේ නම තමයි මට මතක විදියට name netmap.txt ඔක ඔයාගේ නෝට් එකේ තිබුණා okay 22 sorry C uh, host.txt host.txt okay ඒක අපේ නෝට් එකේ නම් තියෙන්නේ නැතුව ඇති බෝ එකට මම ඔය වගේව දාන්නේ අපේ නෝට්ස් වලට මොකද ඕක කටපාඩම් කරාට වැඩක් නැහැ නේ කියලා. නමුත් එක්සැමින් අහනවනේ ඒක තමයි අපිට UCSC නෝට් එකත් බලන්න කිව්වේ. So this should be is it under applications level? Yeah, World Wide Web තිබුණේ application නේ. නැත්නම් ඔගේ reference book එකෙන් දැම්මත් දාන්න. World Wide Web. මෙතින් cookies වලින් අහලා තිබුණේ. right සමහරට මේක reference book එකෙන් අහන්න නැත්තේ. මම හිතන්නේ ඔක ඔයාගේ නෝට් එකේ තිබුණා කියලා. එහෙම නැත්නම් මේක තියෙනවනේ first topic එකේ. නෑනේ. right maybe it's taken from your reference book okay මේ තියෙන bit byte කතන්දරේ right so maybe it's from your reference book I can't remember okay ඒවයි question එකක් විතර දානවා නැත්නම් 100% ගන්නවා right 23 which library procedure does an application program call to resolve domain name into IP address that is domain name to IP translation or we call it IP domain resolution right domain resolution වචනේ තමයි අහලා තින්නේ ඒකට අපි කියන්නේ translator mapper converter කියලා නෙමෙයි resolve වෙනවා කියලා DNS resolution right so the answer is B right 23B okay ඒකත් ඔය නෝට් එකේ ඒ වචනේ ඉතින් කොහොමද ඔයගොල්ලෝ පුරුදු වෙන්න ඕන resolve DNS resolution okay right 24 which tuple in resource record indicates the stability or the reliability of the record අනිවාර්යයෙන් වලට තියෙනවා domain name එක class එක type එක වෙන්න බෑනේ මේක මොකද්ද time to live so කොච්චර කාලයක් මේක කෑෂ් කරලා තියනවද Remember the DNS servers uh, heavily rely on caching, right? So that if someone requests a particular uh, record, so they just put it into the cache so that next time without accessing the disk or file, you can just give it from the memory or the cache. So how long you keep it in the cache, that is called time to live. Okay, time to live. So if that DNS to IP is a stable one, that you don't change it often, this time to live can be higher. So remember, this time to live has so many meanings. Okay, time to live. For example, in routing also there's a the same word is used. That is how many hops it can transmit before it is discarded by the router. If time to live is 10, after 10 hops, 10 routers, the data packet will be discarded. Otherwise, some data packet might ended up right roaming here and there in the internet. No one is discarding, right? So that is why there you have the time to live. ඒකට කියන්නේ time to live කියලා මෙතන තියෙන්නේ resource record ගැන ඒ කියන්නේ DNS records ගැන තියෙන්නේ. හරි ඒකත් ඔයාගේ note එකේ අනිවාර්යෙන් තියෙනවා. තියෙන්න ඕන හරි DNS පැත්තේ. මේ resolve එක තමයි resolve කරන්න කලින් ප්‍රශ්නේ තියුනේ. Right, time to live. Field gives indication of how stable the record is. Right, how stable. ඒ කියන්නේ කොච්චරලා කෑෂ් කරනවද කියන එක තමයි ඔතන කියන්නේ. හරි. මෙතන කියන්නේ කොච්චරලා කෑෂ් කරනවද? So then there's another meaning for time to live. TTL. chat GPT ගාම නිකන් මුත් context එක යනවාදී. What is time to live in networking? මට මතක විදියට අරකටත් කියන්නේ time to live කියනම තමයි. Sorry, live. Values used in network to control how long packet or data is allowed to exist before it is discarded. මේක තමයි සාමාන්‍ය usage එක. Okay? So in IP packets, that is routing. මේක තමයි මම කලින් කිව්වේ. When a data packet travels across internet, it passes through many routers. So each router reduce the TTL by 1. එතකොට පළවෙනි source එකේදී අපි TTL එක දානවා. අපි TTL එක දැම්මොත් එහෙම 5යි කියලා හැම router එකකදී මේක එක එක අඩු කරනවා. මේක බිඳුව වුණ ගමන් router එක ඒ router එක මොකද කරන්නේ? මේ data packet එක drop කරනවා. because එයා දැන් මැරිලා. එයා හරි. ඒක දාන්නේ නැත්නම් data packet එහෙම රවුම් ගහ ඉන්නවා. හරි. So purpose to prevent packets from looping forever if there is a routing problem. Right? So that means if TTL is 64, packet can pass through only 64 routers maximum. So ඔක තමයි standard meaning එක. නමුත් මෙතන කතා කරන්නේ ඒක ගැන නෙවෙයි මෙතන කතා කරන්නේ DNS record ගැන්නේ. Right? So there the TTL is 3600 seconds means your device keep the data resource for 1 hour. Keep the resource කියන්නේ cache එකේ. Okay. After that it asks DNS again for fresh data. Okay. So the purpose is balance speed versus updated information. මොකද ඕනට වැඩි කෑෂ් කරොත් එහෙම වැරදි IPs දෙන්න පුළුවන්. හරි ඕනට වැඩි වෙලාවක් කෑෂ් කරලා තිබ්බොත් මොකද අර IP address එක වෙනස් වෙලා ඔයා පරණ IP address එකම දෙනවා කෑෂ් එකේ. හරි ඕක ගොඩක් පොඩි වුණොත් එහෙම අනවශ්‍ය විදියට ඔයාට ඒ සර්වර් එකට DNS සර්වර් එකට ෆයිල් ඇක්සස් කරන්න වෙනවා රිසෝල්ව් කරන්න. Okay. So therefore we have IPTTL, that is loop limit, and DNSTTL. Okay. Right. ඔය දෙකම ආගේ සිලබස් එකේ තියෙනවා. හරි දෙකම තියෙනවා. අනිත් එක තියෙන්නේ network layer එකේ. Right. Next last question. What is the term for third party code module installed as an extension to web browser? ඒක නැති අපි හැමෝම දන්නවනේ. browser වලට අපි කියන්නේ මොනවද? plugins install කරනවා කියලා. installing plugins. ඒකත් ආගේ note එකේ තියුණා කෙලින්ම. හරි plugins කියලාම නමින්ම තියුණා. application layer එකේ. caching sorry cookies තිබ්බ තැන. unplugging කියලා තිබ්බා. See? Yeah, plugins and help applications. Your browser can have plugins and other help applications. Okay. දවට තේරෙනවද UCSC notes ටික බලන එක පට්ට වැදගත්. හරි. එයා ඇත්තටම එක්සැමිනර් ඉතාලම ලේසි පේපර් එකක් හදලා තින්නේ notes බලපු කට්ටියට. හරි notes බලපු කට්ටියට. Right. After the break we'll move on to the second paper. Okay. Right. So you have two questions and you need to answer all two questions. Okay. Right. So the first question, as I told you, the second paper questions, because networking is a huge area, right? Huge area. So the examiners can ask questions from different areas. So the last year, it's more about IP address, MAC address, IP address to MAC address translation, data packet, data frames, and so on. Some years it is more routing and routing algorithm. Some years it is subnetting, okay, and so on. So let's read this question. So the most important thing is because you have enough time, there's no issue with time for this subject. Okay. Only thing is you need to use your time, read it, understand it, analyze it, and don't be hurried. Okay. Right. So consider the network depicted in the following figure. Right. Machine A, there's a switch, and clearly say it's a LAN 1. And then machine B, remember it says it's a router. Okay, so it's very important to notice that it says it's a router. So then you have the LAN 2. For LAN 1, we have switch 1. LAN 2, we have the switch 2. So basically LAN 1 is machine A and machine B. And machine B act as the router as well. So therefore, machine B is common to LAN 2 as well. So then someone will ask, how do we say that a particular machine belong to both networks? That is why you have two network cards. So basically ETH0 network card is connected to LAN 1 and ETH1 network card is connected to LAN 2. So therefore, these interfaces are in LAN 2. These interfaces RJ45 means normal physical line. So this is, so therefore machine B belong to both because that is a router. Okay. Right. So then let's read it. The interface of machine A is configured with IP address machine A 192.168. You can write it 192.168.1.2.1.2/30. Remember IP address always accompanied by subnet mask or CIDR notation because it's a range of IP addresses, okay, that you are assigned. Of course, this is one of the IP address in that range, okay. A TCP connection is made from port 5248 of the machine. So that is the port that we use in machine A for this particular connection is 5248. That is a port number. That is to identify which software, running software is doing that, making that connection. To the web server running on port 80 of the machine C. So machine C, port 80. So there's a connection between this point and this point, right? Connection, right? It's a TCP connection. Okay. The IP datagram received at C. So when machine A send a request or something, the IT datagram received by machine C over the TCP connection have the source IP as 192.168.1.2. That is same as this, right? So the data packet received by machine C, sent by machine A to this TCP connection has the source IP as this. So that means IP address has not been translated, right? So that is why you get the original, because remember the from hop to hop, MAC address change, right? When a data frame going from this to this to this to this, from this data frame's source MAC address is this one, destination is this one. But when the data frame goes from here to here, the source MAC address is this one, destination is this one, no longer this MAC address is there. So that is how the data frame travel. But if there's a connection between these two, uh, that is data frame, data packet to IP datagram, say source IP address is this one, destination IP address is this one's IP address. So that remains the same throughout the journey. So only possibility of the source change is it going through a network address translation server, NAT server. That is where your local address is translated to public address, private address to public address, right? So MAC address keep changing hop to hop, but source and destination change only if the data packet going through network address translation server. So since we get this IP address as the source IP address, so it has not translated anywhere. Okay, fine. So source address is 192.168.1.2, which is same as this. Okay. The IP datagram received at C over TCP connection have the source IP address and the source port 5248. So that means port number has also not been changed. You can see its original port number is 5248. The data received by machine C, the data packet says its source port number is 5248. That means there is no port address translation also, right, during the transmission, right? No IP network address translation, no port address translation. So we have discussed both these when we discuss the network layer. Okay, right. Uh, the data link frame containing the IP datagram of the TCP connection received at machine C. Remember the machine C get a data frame, right? So for network layer, it is datagram. For the link layer, it is a data frame. Okay, it's a data frame. It's the same data. The way we look at it by different layers, right? So therefore, uh, the data link frame containing in IP datagram of the TCP connection received at machine C has the source MAC as this one. So it says the source MAC is this. So that should be mostly this MAC address of this ETH1 because MAC address is hop to hop. Okay. So this is most probably the MAC address of this. Okay. Uh, and the destination MAC address as this. So that should be your own MAC address, right? Because this is data frame received by machine C. Okay. And it's a hexadecimal number, obviously. Okay. Uh, and those are different. You can see those are different. Right. So the IP datagram of the above TCP connection coming to machine A, that means probably the response. Okay. Uh, coming to machine A have the source IP address as 192.248.17.14. So that should be probably the IP address of this one, assuming no translation has happened. Okay. So let's say this is that IP address. Okay. Because this is a switch. Okay. Uh, assuming that router has not done any translation. Okay. Uh, the ETH0 interface of B, that is this one, has the MAC address of this. So this is the MAC address of ETH0. Okay. An ARP request issued for the IP address 192.248.17.1. 1. 1. What is 192.248.17.1? received එහෙම එකක් දැන්ට තාම මෙයා කිව්වේ නැහැ. මෙහෙම IP address එකක් ගැන first time කියන්නේ. Received a reply within the MAC address uh, with the MAC address of this. ඒ කියන්නේ මොන MAC address එකද? මේ MAC address එක. So that means when you send a address resolution protocol query, that is MAC to IP to MAC, right? ARP and reverse ARP. එතකොට එයා මේ IP එක ගැහුවම එයාට ආවලු මෙන්න මේක කියලා MAC එක. මේ MAC එක කොහෙද තියෙන්නේ? So this MAC address is this one, right? 80027F9CF12. So that means when you do a query, when some machine do a query on this IP address, it is resolved to this MAC address. So that means this MAC address must be assigned this IP address. Again, මේ MAC address එකට තමයි මේ IP address එක assign කරලා තියෙනවා. හරි. ඒ කියන්නේ මෙන්න මෙතන IP address එක වෙන්න ඕන ඕකනේ. So now එතන තියෙන MAC address එකක් දන්නවද IP address එකක් දන්නවද? හරි. Right. What is the IP address of the interface ETH0? That is this one, right? Of the machine B. මතකද මෙයාට වෙනම IP address එකක MAC address එකක තියෙනවා මෙයාට වෙනම මෙයාගේ දෙක දැන් දන්නවා. හරි? Justify your answer. මෙයාගේ MAC IP address එක මොකක්ද කියලා තමයි අහන්නේ. Okay? මෙයාගේ IP address එක that is belonging to this network. Right? Because we have now two networks. Right? So this network and we have another network. So that is this network. Right. So now we need to concentrate on this network. Remember, this is /30 IP address. /30 IP address. එතකොට මෙයාගේ range එකෙන් එකක් තමයි මේ තියෙන්නේ. So this is one of the IP address. So remember /30 means, remember we have altogether 32. 32. Out of 32, this is /30 means only 2 bits for the, මතකයි නේද? Only 2 bits for the host machine. 30 bits for the net and subnet. So only 2 bits for the host machine. So only 2 bits means we have only 4 possibilities. 0, 0, 0, 1, 1, 0, and 1, 1. Right. So that means in this subnetwork, we have 4 IP addresses. Why? /30. And remember, out of the given IP addresses, we need to reserve 2 IP addresses. We need to reserve 2 IP addresses. The smallest IP address is reserved for the subnet ID. The biggest IP address, that is 11 in this case, is reserved for the broadcast. Okay, so then remaining is available for machines or routers or whatever. Right? So this should be one of those available. So then we have only one more available. So ඒක තමයි එහෙනම් මෙයාට දෙන්න වෙන්නේ මේ පැත්තට. මොකද මෙයාගේ දාන්න පුළුවන් usable IP address දෙකයි තියෙන්නේ. Right? So this is 1 2 2 කියන්නේ ඔබේ ඔක්කොම 0 වෙලා මෙන්න මේක වෙන්න ඕන. يعني මෙතන ඉතුරු 6ම 0. So then 1 0 is 2. එහෙනම් අනිත් එකකට යන්න වෙන්නේ ගොඩක් යන්න මොකද්ද? මේ 6ම 0 වෙලා 0 1 තමයි ගොඩක් යන්න වෙන්නේ ඉතුරුලා දින ඔච්චරයි. මෙයාට 1 2 දුන්නා නම් එහෙනම් මෙයාට දෙන්න වෙන්නේ මොකද්ද? 1 1 තමයි දෙන්න වෙන්නේ. 192.168.1.1 because 10 is for the subnet ID, 13 is for the broadcast ID. So therefore 192.168.1.1/30 is the only available IP address because this is a /30 network. Okay. So is that the answer? 1 1. 192.168.1.1. Yes, right. 192.168.1.1/30. Because it's a /30 network, we have 2 bits to play. That means 4-bit patterns. Out of 4-bit patterns, the 0, 0 and 1, 1 is already reserved. So therefore, this one has been reserved, given the 1, 0. So then this must be given 0, 1. 0, 1 means 1. Okay. හොඳට explain කරන්න. මීට වැඩි හොඳට explain කරන්න පුළුවන් වෙන්න ඕනේ. හරි. මෙතන only 2 machines can be network because remember 2 bits means 4. four patterns. Out of four patterns, two first and last one is reserved. ඒවා කියලා නෑ ඒවත් ලියන්න. Okay. So and again ඊට පස්සේ කියන්නේ මේ pattern එක දීලා තියෙන්නේ. Two is this pattern. So then these two patterns we can't use. So then this is the only available pattern. So එයා ඔක්කොම මේ අනිත් හයත් එක්ක ගත්තා මෙන්න. මොකද මේ හය 0 0 0 කියලා දන්නේ මොකද මෙයා 2 කියලා දන්නා හන්ද. Right. මොකද මේ ටික වෙනස් වෙන්න බෑ network එකේ. So likewise you need to explain. Okay. Right. So it's not impossible question, right? But you need to understand all these concepts of subnetting, right? Subnetting, address resolutions, network address translation, port address translation. එහෙම මුකුත් උන්නේ නැහැ කියලා කරන්න තමයි අපිට මේ දීලා තියෙන port numbers, IP addresses ආපුවා මේ පැත්තට. හරි. Right. So any questions? Right. Second question. Second B part. What is the MAC address of the interface ETH1 of B? Justify your answer. Justify කරන්න ඕන. ETH1 of B. So ETH1 of B. ඒක වෙන්න ඕන මොකක්ද එහෙනම්? 80027 F9 CF12. Right? F9 CF12. ඒක කෙලිම question එකෙම දීලා තියෙනවා නේ. Right? Because it says the data frame containing IP datagram of the TCP connection received at machine C. ඒ කියන්නේ මෙයාගේ data frame එකේ MAC address එක විදිහට තියෙන්නේ මේක නම් ඒ ඇවිල්ලා ඔයාගේ ඊළඟ තැන. මෙතන ඉඳලා මෙතනට එන්නේ කලින් hop එක. Right? So that you need to explain like that. Packet from A are forwarded to C through the interface ETH1. These Ethernet frames have the source MAC address. So මෙයාට ආපු source MAC address එක තමයි මෙයාගේ MAC address. switch වල MAC address වෙනස් කරන්නේ නේ. Right. C. මේවයි question නිතර අහනවා. හරි. ඔයාලා කලින් අවුරුදු වලට ගියාම මේවයි questions තියෙනවා. What is the IP address assigned to the interface ETH1 of B? ETH1 of B. ETH1 of B කියන්නේ මෙන්න මෙතන. ඒක ගන්න අපි අර address resolution protocol එකෙන් ආපු query එකෙන් because from that we can say that its IP address must, because this MAC address is resolved to this IP address means this must be the IP address of this. Right? Right? So therefore IP address of ETH1 must be 192.248.17.1. 17.1. ඔයා කියන්න ඕනේ මේ ARP resolution එකෙන් තමයි අපි මේක ගත්තේ කියලා. Because ARP says for this MAC address this IP address and we already know that this is the MAC address of that. So therefore this must be the IP address of that. 100% logical thinking and critical thinking. And of course know your subject. Know your subject. Subnetting, how the data frames going from hop to hop, how the data packets transmit, what is address translation, network address translation, network port translation. ඔක්කොම තියරි ඉගෙනගෙන තියෙන දැන් දැන් මෙතනින් එහාට ඔයා තමයි ඔළුවෙන් ගේම ගන්නවා. Right. D. What is the IP address of the only network interface of C? Justify your answer. Right. Only network interface of C. C එකේ තියෙන එක interface එකයිද? ඔව් C එකේ තියෙන එක interface එකයි. C ටයි ඒටයි තියෙන එක interface එකයි. මෙයාට තමයි interface දෙකක් තියෙන්නේ. මෙන්න මෙතන interface එකේ network IP address එක අහන්න. IP address එක දැනටම අපි හොයාගත්තේ නේද? එයාගේ IP address එක වෙන්නේ මොකද්ද? මෙන්න මෙයා. Why? The IP datagram of the above TCP connection containing machine A have the source IP address of 192 blah blah blah. මේක කියලා තියෙන්නේ. Okay. About TCP connection එකේ so මෙතන ඉඳලා කියවන්න ඕන. The data link frame containing the IP datagram of the TCP connection received at machine C has the source MAC address of this and the destination MAC address of this. එයාගේ destination MAC address එක විදිහට තියලා තියෙන්නේ මේක. The IP datagram of the above TCP connection contained in the machine have source IP address of this. හරි. එයාගේ source IP address එක විදිහට තියෙන්නේ මෙන්න මෙයා. IP datagram of the above TCP connection contain coming to machine A. machine A එකට ආවේ මෙතනින් ගියේ. machine A එකට ගියේ C වලින්. එහෙනම් C ගේ IP address එක තමයි source එක විදිහට තියෙනවා. ගිහලා ඔක explain කරන්න. So therefore it is 1714. Right, 1714. Right, IP datagram of the above TCP connection coming to A has the source IP address. අන්නේ වාක්‍යෙන් තමයි අපි ගත්තේ. Right? Right, E part. Any questions, right? මේක තේරෙන්නේ නැත්නම් තියෙනවා අහන්න ඕන. හරි. So you need to be serious, right? You are now in semester 4, level 2, higher diploma. And you have the chat GPT, Gemini, YouTube, right? Use all the resources. Your task is understand, be serious, right? Not memorizing that this and that and other thing. Right? ඔළුව ගෙනියනන් වගේ exam paper එක ගැන විතරක් හිතන්න එපා. හරි. Your task is understand. Right? So that you convert into confidence and later on after getting your degree or whatever, or even now, apply for exams, go for interviews, right? Make money, enjoy your life, right? Face challenges, right? Does the TCP connection from A to C go through network address translation? Justify your answer. No, because if there's just network address translation, these IP addresses must have been changed, right? එහෙම change එකක් වෙලා නැහැ. මෙහෙන් යන IP address එක මෙතනට ඇවිල්ලා තියෙනවා. And මෙහෙන් යන port address එක මෙහෙට ඇවිල්ලා තියෙනවා. So therefore, so the same IP address going from C received by A, same port address received by A. So therefore, neither in NAT nor PAT is used in this network. Okay. So IP data, yeah. The datagram received at C has the source IP address of A, and the source port is same as the source port of A. So that means IP address has not been translated, port address, port number has not been translated. So therefore, no, nothing like that has happened. Right, that is the question number 1. Okay. Right, question number 2. Question number 2, good theory. Theory. හරි. ඒක ඉතින් මතක තියෙන්න ඕන සමහර දේවල්. List down 4 components of the TCP header other than source port and destination port. ඒක කාටවත් මතක හන්ද ඒක අහලා නැහැ. source port එකයි destination port එකයි තියෙනවා නේද? IP header එකේ තියෙනවා source IP address, destination IP address. In TCP header, remember data packet has the IP header, TCP header, if it is web related HTTP header. හරි වෙන වෙනම headers තියෙනවා. ඒකට TCP header එකේ තියෙන අනිත් ඒවා මොනවාද කියලා අහනවා. මතක නේද TCP header එකේ ගොඩාක් තියෙනවා. UDP header එකේ තියෙන බොහොම පොඩ්ඩයි. Right? Because TCP header is related to reliability connections. Okay. Right. So that's your topic number 4, right? Yeah, transport layer. වෙනම diagram දෙකක් දීලා තිබුණා. TCP header එකේ තමයි packet number එහෙම තියෙන්නේ. Packet sequence number. So this is UDP. Just source port, destination port, UDP length, UDP checksum. Very simple. Okay. And few more flags. But when it comes to TCP, this is UDP usages. This is RTP. Right. So when it comes to TCP, we have so many other flags. I think sequence number is there because you need to make sure that the data packets are assembled properly. Acknowledge number. Why acknowledge number? Because remember TCP is a connection oriented. We send the acknowledgements. And we have the window size and many other flags. Fin flag, sin flag, and so on. Okay. ඒවෙන් ඕන එකක් වාට ලියන්න පුළුවන්. ඕන එකක් ලියන්න පුළුවන්. හරි? Urgent pointer, checksums, window size, acknowledgement number, sequence number, and so on. That is not an unfair question, right? මොකද ගොඩක් තියෙනකොට වගේ flag තව එකක් දෙකක් හතරක් ඇහුවට වැරද්දක් නැහැ. Right. Describe the process of connection release. Remember in TCP, you need to understand how the connection is established, how the connection is released, right? Handshakes, right? Handshakes. Uh, so this is how the connection is established. Three-way handshake. Three-way handshake. මොකද දෙපැත්තම දැනගන්න ඕන දෙපැත්තට communicate වෙනවා කියලා. Okay, so you send the sequence number, you get the sequence number plus one plus new sequence number. Then you send the original sequence plus number plus one plus whatever the received plus one. So then both parties knows that two-way communication happened. Right? For example, when host one received x plus one, ඔයා යවි 6 නම් වාට 7යි කියලා කොන්දවා දන්නවා. Host 1 host 2 can receive and send කියලා. Then මේ ඒක confirm. ඒකනේ send and receive කරන්න පුළුවන් හදනේ. ඔයා 10යි කියලා 11යි කියලානේ. හරි. ඊට පස්සේ එයා තාම හැබැයි host 2 දන්නේ නැහැ. Now host 2 knows that host 1 can send. But host 2 still doesn't know whether host 1 can receive. මොකද ඔයා මේක යවුවට මේක හම්බුණාද දන්නේ නැහැ. So that is why again host 1 increment your y value by 1. If you send 20, you get 21. Now now host 1 is මෙතනට එනකොට host 1 දන්නවා host 2 ඉන්න එයාට receive කරන්නයි set කරන්නයි පුළුවන් කියලා. හැබැයි මේ වෙද්දි තාම host 2 දන්නේ නැහැ host 1 ට receive කරන්න. Now host 2 knows that host 1 can send. That is why you receive this. But once host 1 reply incrementing your y by 1, now only host 2 knows that, okay, my host 1 can not only send, host 1 can receive as well. Host 1 has received my y value, that is why host 1 send me the y plus 1. මේවා නිකන් කටපාඩම් කරන්න එපා හරි. මේවා ඇයි කියලා දැනගන්න ඕනේ. මොකද මැසේජ් යවන්නේ ආතල් එකට නෙමෙයි. හරි. මැසේජ් යවන්නේ අත්‍යවශ්‍ය අවප්‍රමාණය. So that is called two-way handshake. But the question is not related to connection establishment, it's related to connection termination, right? Connection release. Okay. So remember, it's a two-way connection. You need to release both ways. Both ways. You can see when both directions are shut down, the connection is closed. දෙකම දෙපැත්තම shut down කරනවා. Right? එහෙම නැත්නම් එක පැත්ත බලන් ඉන්න තාම connection එක දිහා. Okay. ඒක තමයි මෙන්න මේ ඊට වැඩි ලොකු කම්ප්ලිකේෂන් එකක් තියෙන මැසේජ් ටිකක් යවන්න ඕනේ. කොහෙද ඒක තියෙන්නේ? ඒ ඩයග්‍රෑම් එක ඇතුළේ කනෙක්ෂන් රිලීස් එක අමාරුයි එක්ස්ප්ලেইন කරන්නත්. මේ ස්ලයිඩින් වින්ඩෝ එක. හරි. මේ ස්ලයිඩින් වින්ඩෝ කියන්නේ මොකද්ද? හැම එකටම රෙස්පොන්ස් යවන්නේ නැහැ. ඔයා එකතු වුණාට පස්සේ රෙස්පොන්ස් යවන්නේ. ඒ කියන්නේ ඔයාලට මැසේජ් 10ක් විතර ආවම තමයි මැසේජ් එකක් යවන්නේ ඊළඟ ටික ආයි සෙට් එක යවන්නේ කියලා. මේ කතන්දරේ ඒක නෙමෙයි. හරි. මේ කතන්දරේ ඒක නෙමෙයි. කනෙක්ෂන් ක්ලෝස් එකට ඔයාලට සිම්පල් මැසේජ් එකක් තියුණාද? නෑ. මේ ඇවිල්ලා කන්ජෙෂන් කන්ට්‍රෝල්. එහෙනම් ඔයාලට මේක තමයි අඳින්න වෙන්නේ දැන්. හරි. This is sliding window. මේ connection closing නෙමෙයි. So you need to draw this part then, closing part. මේ තියෙන establishment part. ඒක ටිකක් දිගයි.
Sir, we do have four-way handshake in our notes.
Four-way handshaking.
In our Aurora computer studies
Our
notes.
note we have simplified version. Okay, let me double check. I didn't double check that. Okay, I just only check the UCSC note. That is in TCP, right? Yeah, TCP. Computer networks. Transport layer. Right, so this all right. So our note has a simplified version. Okay, simplified version. three-way handshake. Here we have four-way handshake. So client send M, server send M plus one, and then server send N, and client send N plus one. So why do we need four-way handshake? I have a four-way handshake. Three-way handshake.
Because we do have two-way communication, so we need to close the both
But
ways.
here also we can establish a two-way communication, right? So we established a two-way communication. We ended up the two-way communication. So why do we need four? So can't we just stop at this point? So this guy said X, this guy said X plus one.
Sometime packet will get delay in traffic, so we need to have timeout.
No, I don't think that is a good answer, right? So now this guy says, inform this guy. Okay. But this guy need to respond. This guy need to respond. If without responding, still this is not complete. Okay.
Because sometimes if we close the connection, requests can come, so we need to send again.
I'm not very convinced. I can't remember the exact reason. Shall we ask ChatGPT? Because that can be another question. I can't remember exact reason why we need four messages. Okay. So there should be a good reason. So why four-way handshaking is required for termination of connection, whereas three-way is enough for connection establishment. We'll give the diagram also. Diagram value add. Okay, let's ask from this. Yeah, that is three-way communication. Closing one direction does not necessarily mean closing the other. Suppose the client is finished sending data. Uh, that is, you are sending the fin message. I have no more data to send. The server may still have the data to send back. So the server replies the acknowledgement. At this point, client to sender channel is closed. Still sender to client channel is open. Then make it acknowledge kara hari A to B close කර කියලා. හැබැයි තාම B to A තියෙන්න පුළුවන්. දැන් ඒ පැත්තත් close කරන්න because the idea is flexibility of either closing one way or closing both ways. Sometimes you just want to close one way. Other way still you want to keep. Sometimes you want to close both ways. So therefore, rather than closing both ways blindly, so first two message only confirm A to B is close. Then the B must send your fin message and that must be acknowledged. So then you close the other way. Okay, so therefore basically you close one way at a time. One way at a time. So that is why we have four messages. Okay. Because the server may not ready to close immediately after receiving the client's fin uh, until it has finished sending its remaining data. Yeah, there can be some remaining data also. So therefore, maybe you close it later. You close it later when So when you are ready to disconnect the other way, then only we send the fin message. Okay? Then only we send the fin message. So that means we can close A to B, but still we are not ready to close B to A. Maybe we need to send some more acknowledgement and so on. Okay. So therefore you do it separately. Okay. Can terminate sometimes use only three packets. Yes, if the server has no more data to send, when it receives fin, it can combine acknowledgement and fin. That means if B has nothing to send, uh, so then he with the acknowledgement uh, of the A, it can send the fin for the B as well. So then just the acknowledgement. So then we can do it in three way. But in general, four way. In general, four way. But if B has nothing to send as well, so then it can convert it to three way as well. Okay. Right. So because these are possible questions. Okay. These are possible questions. So typically four, but sometimes it can be done in three ways as well. The termination. Okay. But establishment is always three way. But establish කරද්දී එක පැත්තක් establish කරනවා කියලා නෑ දෙපැත්තටම establish කරනවා. Okay? Because you are supposed to send acknowledgements. Right. So what about the next question? Right. So this explain the communication. Okay. So when both directions are shut down, the connection is closed. So one fin and one neck for each. ඒක තමයි අපේ note එකේ තියෙන one fin and one neck for each කියලා. Right. One fin and one neck for this way communication, another fin and act for this way communication, right? Three-way connection, four-way connection termination. But this can be uh, combined. These two can be combined uh, to make it three-way as well in some cases. Okay, right. Explain the hidden terminal problem in wireless network. මේක නම් අපි මම හිතන්නේ සතියකට දෙකකට කලින් දුකද කතා කරේ. Wireless communication, right? So our diagram එකක් ඇඳලා explain කරන්න පුළුවන්. That is an easy question. Right? So we have this machine, this intermediary point, access point or whatever, then this machine. Right? So this machine can see this point. This machine can see this point, but these two machines are far away, so therefore this machine can't see this one. But in reality, though this machine can't see this machine should be able to send data to this machine because through this, but this machine can't directly see this, right? Directly see this because they are far away. But definitely this machine should be able to send data to this machine through this. So therefore it's a hidden node problem, right? You are supposed to access it, but you can't see it, right? So you need to explain like that, okay? Like this. Okay. So A and C want to transmit to B. Okay, A and C want to transmit to D. Now C can see it, but A can't see it. But actually A can send it through this. Okay. Therefore, A is transmitting. C cannot sense it. Though it sends the medium, if C එක කියලා තියෙන විදියට නම් හරි සෞත්තුයි. කෑලි හැමෙන් ඔමුලා තියෙන්නේ. If C start transmission, collision may occur at B. හරි. මෙතන වෙන්නේ ඇත්තටම මෙතන අනිත් පැත්තට explain කරලා තියෙන්නේ. A can't sense C, C can't sense A, but actually if C send a data packet and A also send a data packet at the same time, those collide. But actually C cannot sense A's traffic, A cannot sense C's traffic. So therefore they can't sense each other's traffic. If both send the data at the same time, those get collapsed. Okay. So I think that is the standard explanation in your note. Okay. ඔතන කතන්දර දෙකක් තියෙනවා එකට explain කරලා. හරි hidden terminal එකයි. Oh, let's open the note. මේ දෙක පැටලෙනවා සමහරවිට. There was that. That should be under network layer. Network layer wireless. There was that question topic.
So I think under data link layer.
Data link layer. Yeah, definitely we had this. Yeah, just like Aloha and so on. Uh, for the wired. Uh, yeah, data link layer. So this is wired, right? This is ring topology. Yeah, wireless. So remember the extended service set, basic service set. Possible issues are, you can see hidden terminal problem, exposed terminal problem. Two problems, okay? So hidden terminal problem, uh, A and C want to transmit to B, right? Remember A and C can't see each other. So therefore C thinks that line is free, A thinks that line is free, and both send at the same times and collide. Yes. A and C want to transmit to B, but C is not within the range of A. So therefore, A want to transmit to B, C want to transmit to B, but A and C can't see each other, sense each other, traffic. So therefore, A send data to B, C send data to B at the same time, those get collided. Okay. So if C start transmission, collisions may occur at B. When A has transmitted, if C also transmit, collision happens at B. So that is called hidden terminal problem. හරි මම ඉස්සෙල්ලා එක්ස්ප්ලেইন කරේ අතන hidden terminal problem එක නෙමෙයි මොකද්ද exposed terminal problem right so B needs to transmit to A right B needs to transmit to A and C need to transmit to D right C need to transmit to D if C sends the medium while B is communicating with A right so now B is communicating with A it has nothing to do with this transmission okay but C feel like the medium is occupied, but actually it's occupied this way. This is free, but C thinks it is not free, right? So therefore C is not sending, but actually C can send it. Okay. So though C and D can do the communication, it is prohibited because of the exposed terminal problem. මෙතන ඇත්තටම කරන්න පුළුවන් නමුත් සිස්ටම් එකේ සෙන්සර්ට අනුව කියන්නේ කරන්න බෑ කියන. That is called exposed terminal problem. Okay. Right. So then ඊළඟ අහන්න පුළුවන් වාට මොකද්ද මේ passive scanning versus active scanning remember in uh, you use something called bacon token හරි මේකත් පොඩි නෝට් එකක් ලියා ගන්න මේක මම නෝට් එක දිගට දීලා නැහැ මෙන්න මේකේ තියෙනවා bacon token එකක් යවන කතන්දරයක් ඔක අහන්න ඉඩ තියෙනවා හරි මම නෝට් එක දුන්නේ නැහැ එතන නිකන් ස්ක්‍රීන්ෂොට් එකක් ගහම එයා එක්ස්ප්ලেইন කරන කොටක් යට හරි you can see bacon frame එකක් යවනවා අපි passive scan එකේදී so it explain this because examiner can ask more detailed questions about that also. Okay. Right. So just make a small note on this because examiner එතන ඉන්න හන්ද ඔය හරිය කරගෙන පුළුවන් ආයි. Right. What is virtual LAN? So we discussed virtual LAN. I think that just one before the last topic. So virtual LAN means it's not physically separated into subnetwork. It's physically the same network, but virtually, logically, we break it into subnetworks. Subnetworks. Okay. Through other concepts, like mapping of IP addresses into different subnetworks, or even MAC addresses into different subnetworks. Mostly mapping MAC addresses into subnetwork. So then your router knows that these MAC addresses belong to, say, virtual LAN A. These C subnet MAC addresses belong to subnetwork B. So then when you fix it, where it doesn't matter from where you fix your connect your laptop or tab, uh, you are connected to the correct LAN, because MAC addresses are mapped to different LANs. එහෙම හදන්න විදි ගොඩක් තියෙනවා. ඉස්සර නම් ෆිසිකල් පෝට් වෙනම තිබුණා. දැන් එහෙම හදන්නේ නැහැ. එතකොට ෆිසිකල් වයරින් කරන්න ඕන. දැන් ගොඩක් අයට virtual LAN හදන්නේ එහෙම MAC address හරි IP address level එකේ. Okay. It's a logical grouping of network devices that allow segmentation of physical local area network into multiple distinct broadcast domains. So the segment is done at data link layer. ගොඩක් අයට මේක කරන්නේ level 2 එකේ MAC address වලින්. And the other advantage is you can configure such that a particular machine belong to more than one LANs, more than one VLAN. VLAN දෙකකට විතර ඕනනම් ඔයාලට එක machine එක part කරන්න පුළුවන්. Okay. Right. Illustrate the architecture of email system using a diagram by including all the necessary components. So that is a typical diagram, right? So you need to show uh, the mail clients, mail transfer agents, okay, mail transfer agents, maybe you can show the SMTP is used from sender to the sender server to the receiver server, and from receiver server to the receiver, it is POP IMAP, right? POP IMAP. මෙතන IP මේවා නම් පෙන්නලා නැහැ. හැබැයි senders use agent, receivers use agent, message transfer agent for the sender and message transfer agent for the receiver. මේ පෙන්නලා තියෙන SMTP කියන්නේ. ඇත්තට මෙතන විතරක් නෙමෙයි, මෙතනත් SMTP, but here it's POP IMAP. POP IMAP. Okay. Right. So that's it about 2024 paper. Okay, 24 paper. Right. So we'll take a small break. After the break, we are going to do project management. We have two more topics to finish. Out of those, we are going to do the project. Sorry, we have three more topics. Okay. Out of those, we are going to do project schedule management. Okay, so let's move on to project management. So our next topic is project schedule management, right? So we want to finish that today. Right, so now we have started past papers for Agile. UXD, we did a past paper yesterday. So then computer network also we have done past papers. So tomorrow we will start past papers for EAD. Okay. Right. So project schedule management. So these are the two topics, the critical topics for the exam as well. Okay. Schedule management and cost management, especially for the second paper. Right. So let me open the note. Our note. Okay. Okay. First, I will use UCSC note. Yeah. So that is better. We'll use both the notes. Okay. Software project management. sorry, IT project management, right? Yeah, IT project management. Right. First, let's go through our note. Then I'll go through UCSC note as well. Right. So project schedule management is another way, time management. Right. Remember, cost, time, scope, quality. Those are the four key aspects. Right. We have done uh, quality, I think. Yes, we did quality, but not time and cost. This is time. Schedule is time. Okay. Right. So the idea is we need to deliver on time, of course, on time, within budget, the promised scope with expected quality, right? So one aspect is we need to finish within the time schedule, right? Without delays. So how to do that? We do schedule management. Okay. So this is a common issue in IT projects. That is, we schedule for say 3 months, but at the end of 3 months, we have not done. Okay. So there can be so many reasons. One is inaccurate estimates because it's very difficult to estimate tasks for project software projects. It's not like civil engineering projects, right? Where you know how many hours it take to build a particular wall, square feet, level, and so on. Okay, and also poor change management. It's in a way it's poor change management. At the same time, it's the reality, right? Changes can come because we are developing business systems. And of course the people's attitude towards schedules. So some people, so their attitude is until the deadlines are closer you don't do anything. So when deadlines are closer you try to do everything, especially in eastern culture. And of course the schedule delays often result in cost overrun as well. So the schedule is dragging means the cost is also going up. Okay, so those are real issues. So these are the schedule management tasks. We need to prepare the estimates, prepare the schedules, and control the schedule. Because if things are not going according to the schedules, we need to take some actions. Right. So how to prepare estimates? Right. So without estimations, how can we schedule? Because we need to have estimation. Right. So this task will take this much of time or this much of effort is needed. Okay. So typically it is done this way: size, effort, time, cost. So now remember when we develop a software, we first identify tasks. This task, this task, this task. Okay. Maybe requirement analysis. Right? Gather, analyze, model, then designing aspect, high level design, architecture, UI design, database design, then development of particular use case, another use case, testing, unit testing, system testing. So likewise, you need to identify the tasks, right? So then you need to identify the size of the tasks. That is the hardest thing because these tasks are different types. One is analysis task, another one is designing task, another one is testing task, another one is development task. So especially for development tasks, we can do certain level of estimations like relative sort of a size estimation. So there are two approaches: top down no analogy approach, that is the most widely used, a bottom up approach. Okay. So top-down no analogy approach means we look at the similar projects, past projects, and try to understand how much of a effort is required to do this kind of a task. How many man days, how many man hours. Again, it can be developer hours, QA hours, testing hours, and so on. So that is called analogy approach. So you need some experienced people to do that, experts who has some past experience. So second approach is bottom-up approach. So there we break down your task into smaller and smaller tasks and then do the estimate of these tasks. Then sum it to estimate the bigger tasks. Okay. So this is very difficult task because estimating the effort or size of a task is very difficult because the technology vary, complexity vary, and so on. Okay. And also, especially when it comes to time scheduling, it depends on uh, the size of a work as well as availability of the resources, and not only that, the talent of the person. Maybe one person can do it in one day, another person might take it maybe 3 days. Okay. And also there are dependencies between tasks. So we can't do this, we cannot do this until this is done. So though time is allocated, maybe still this is not ready. So there are so many complications. So many complications. Okay. Right. So these are some techniques we use to do these estimates. So one technique is PERT technique, program evaluation and review technique, PERT. So in PERT technique, it's a probabilistic 3-point estimation because we can't say exact time or effort. We come up with 3 values. Most likely value, say most likely, the developer will say, okay, most likely I will do it in 3 days. But if everything goes well, maybe I can do it in 2 days. So that is optimistic value. But this is something I'm doing this for the first time, maybe. Right? There are some fuzzy areas. So therefore, worst case, maybe I need 5 days. So that is called 3-point estimate. Most likely, optimistic, pessimistic. Okay. So use these 3 values. And again, how to calculate these values is subjective. It depends on the person and so on. Okay. And also the nature of the task, technology, and so on. Right. So when we do scheduling, first we need to come up with a work breakdown structure. That is breaking your task into smaller and smaller tasks. And also identify dependencies. Right. So task into activities, then how these tasks are sequenced, because after this task only we can do this task, and dependencies. Sometimes you need to do both these tasks to start this one. And also milestones. Milestones are important time points where we do a release or something. It's an important uh, time for your project. Mostly milestones are related to releases. Releases. So these are the terminology. Okay. So as I told you, WBS means you break down your task into subtasks. Subtasks. Right? So this is an example of a WBS. Just an example. Right? Project initiation, it's subtasks. This is more like a waterfall approach, not iterative project. Requirement analysis subtask, design subtask, implementation subtask, and so on. So this kind of structure is called WBS. Okay. Or if it is iterative, so each iteration you have a subtask. Right? Each iteration you have a subtask. Maybe each iteration we have milestones. This is assuming it's waterfall like a sub project. Okay, just to make it easier, simple. Okay, right. It's the same thing twice. Okay, I think it's a duplication of slides. Right. So then we can identify the activity list. So these are the all the subtasks, all the subtasks. So when these subtasks are done, your bigger tasks are done. Okay. So usually we give them the give a name, an identification number, and a description. Okay, for project management purposes. And what are the attributes of an activity? Of course, other than the activity name, activity description, and activity number, so there can be predecessors, successors. So that means in order to do this task, we need to do these tasks. Successors, after doing this, only we can do these tasks. Okay. So likewise, there are constraints, assumptions about the task, and so on. So these are called attributes of a particular activity. So milestones I already explained. So milestone is a significant event in your project. Mostly milestones are releases. So project managers try to achieve these milestones. If there's a milestone in this Friday, we try to achieve that in this Friday. Try, right? It's not certain. Right? Sequencing activities means you arrange the activities according to the dependencies. Because sometimes you can't do B without A. So then you need to finish A to start B. Okay. So these are the three type of dependencies. Now, after this session, you immediately go through the UCSC note. Okay. Because 90% of the UCSC notes contents are here. So what are the three type of dependencies? Mandatory dependencies, discretionary dependencies, and external dependencies. So mandatory dependencies, sometimes we call it hard logic. So that means due to the nature of the task, this dependency is there. You can't say no. For example, without writing the code, you can't run unit test. So therefore, without until you finish your development of the unit, you can't do the unit testing execution. Maybe you can write the testing, but not the execution. Right? So that those are mandatory dependencies. Mandatory dependencies. Most of the time, what we see is mandatory dependencies. So then we have discretionary dependencies. Sometimes we call them soft logic. Yes. So those are more defined. This is more due to the nature of the work. This is more due to the uh, project team. Okay, project team. Right. So sometimes it may be you need that particular resource to do two tasks, but that resource you can't allocate for both the tasks parallelly. Okay. So those are discretionary dependencies. Maybe we have a little bit of flexibility, but sometimes we need to work with those restrictions. So external dependencies are beyond our control, like some delays from customer, right? Sometimes we are expecting a server, but you can't get the server until it's another 10 days. So those are beyond our control. So those are called external dependencies. But when we schedule, we need to consider this because, for example, if the server is not ready for 10 days, so you can't do that particular task that you need that server, right? Right. So this is another classification. These are the types of dependencies. Now this is how these dependencies can happen. Right? So first one is finish to start dependency. This is the most important and most we consider only this one in our scheduling. So that means in order to start B, A must be finished. So that is finish A to start B. Finish A to start B. This is the mostly this is the one that we are really concerned. So then start to start. So that means in order to start B, you need to start A. So that means you can't start B without starting A. Finish to finish, you can't finish B without finishing A. So next one is start to finish, right? So that means in order to finish B, you need to start A. So those look strange, right? So this looks very natural, right? In order to start B, you need to finish A. අපි තු මෙයාගේ ඉන්න software developer මෙයාටත් මේ task එකට දානවා. එතකොට මේක ඉවරනවා තමයි මෙයාව දාන්න. Okay. Or else we need that particular tool to do this task B, but that tool is currently used by A. Then after finishing the A, the tool is available. So then only we can start B because that tool is essential. So those are finished to start. So start to start means you can't start this unless this is start. So can you think of an example like that start to start? Okay. So those are pretty much parallel tasks. You can do it parallelly, but though it's parallelly, say X can do when Y is done, but parallelly. So we can do it parallelly, but when this is done, only this can be started. When this is done, only this can be started. But it's happened parallel. Okay. So that is called start to start. Then finish to finish. You can finish B only when A is finished. So මේකට ප්‍රැක්ටිකල් එක්සාම්පල් එකක් තියෙනවා ප්‍රොජෙක්ට් මැනේජ්මන්ට් වල අදාළ නැහැ. අපි වාහනයක් තල්ලු කරනවා. වාහනයක් තල්ලු කරනකොට අපි දිගටම තල්ලු කරගෙන යනවා. ස්ටාර්ට් වෙලා ඉවරුනහම තමයි තල්ලු කරන එක නවත්තන්නේ. ඒකට මෙයා ෆිනිෂ් වුණාම තමයි මෙයා නැත්තම් ඒක ඇත්තටම ස්ටාර්ට් ටු ෆිනිෂ් ෆිනිෂ් ටු ස්ටාර්ට් කියන්නත් පුළුවන්. නැත්තම් මෙයා එහෙම කියන්න බෑ. හරි. මෙයා ෆිනිෂ් වුණාම තමයි මෙයා ෆිනිෂ් කරන්න පුළුවන්. ස්ටාර්ට් වෙලා ඉවරුනහම තමයි අපි තල්ලු කරන එක නවත්තන්න ඕන. Okay. That is like finish to finish. So then start to finish means we can finish when this start. And ඇත්තට මේක තමයි වාහනය තල්ලු කරන එක. Start to finish. So when this start only we can finish it. ඒ කියන්නේ අපි තල්ලු කරන එක නවත්තන්න පුළුවන් මේක පටන් ගත්තම නැත්නම් එන්ජින් එක ස්ටාර්ට් වුණා. So that is start to finish. Okay. So finish to finish means we can finish this only this is finish. හරි අපි හිතමු මෙයා කපරාරු කරනවා කියලා. මේ තීන්ද ගන්නවා. හරි මෙයා කපරාරු යනකොට අපි තීන්ද ගන්න පටන් ගන්නවා. මෙයා කපරාරු ඉවර කරනකම් අපිට තීන්ද ගන්න ඉවර කරන්න බෑ. මොකද තීන්ද වලින් වැහෙන්න බෑ. So that is plastering versus painting. Right? So we can finish this only when this is finished. Okay. Right. But we are more interested about finish to start. So you need to understand these things. Otherwise, you will blindly memorize. Okay. Right. So then we will look at what is mean by critical path method, CPM. Okay. So the best thing is we will look at an example. Okay. We will look at an example. So there are two approaches. Let me open your UCSC note also parallelly. So defining activities, activity lists, activity attributes, milestones, sequencing attributes based on dependencies. The three type of dependencies: mandatory, discretionary, and external. Right. So when it comes to scheduling, we use two type of scheduling diagrams. Right. What are those? Activity on arrow diagram. Okay. Activity on arrow diagram means the activities are in the arrow. So these are activities: A activity, B activity, C activity, D, E, F, and so on. Okay. So that is called arrow diagrammatic method or activity on arrow diagrams for scheduling. Okay. How to prepare this diagram? I will explain later. Right. Activity on arrow, or another name is what? Arrow diagramming method. Okay. So then there's another approach. මේ dependencies ටික අපි දැන් කතා කරා, start to start, start to finish. So the other approach is, so 3-point estimates also we discuss. Okay. So this is activity on node. So we have two approaches: activity on node or activity on arrow. So this is activity on arrow. Okay. Activity on node, activity on arrow. So let's first look at how to use activity on arrow, because that is easier, but it has less features, less useful. Okay, less useful but easier. Right. That is activity on arrow, or you call it arrow diagrammatic method. Okay. Right. So this is how you do it. So let's take an example. Okay. Say these are our tasks. These are our tasks. A, B, C, D, E, F, and these are the duration of the each and every task. Okay, so let me open your presentation. That's easier. Right, so these are the tasks, these are the durations, and these are the dependencies. That means you can start A without, there are no dependencies. That means straight away at any time you can start A. It take 2 days. So then B and C can start. We can start B or C only when A is done. These are start to finish dependencies. So only when A finish, we can start B. We can start C. And only when B finish, we can start D. And only when C finish, we can start E. And only when D finish, you can start F. Now you can put it into a simple activity on node diagram. අපි ඉස්සර කතා කරන්නේ activity on node because it's easy. So you can start A at any time. Right? No dependencies. Now once A is finished, only we can start B. And also we can start C. Right? So when B finish only, we can start D. And when C finish only, we can start E. This is very easy, okay? And when D finish only, we can start F. So this is the dependencies. So these are the activities. So therefore we say activity on node. Better than the activity on node. Okay? Not activity on arrow. Okay, activity on arrow. This is activity on node. Okay? Now I will do it activity on arrow. So why we say node? These are the nodes. So in activity on arrow, so A, you can start no dependencies. So therefore we can say this is my A. Right? Now you can see my activity is in the arrow. So then when A is done, we can start B. And not only that, we can start C. We can start C. Okay. And when B is done, we can start D. We can start D. And when C is done, we can start T. And when D is done, we can start F. Okay, we can start F. So this is activity on node. This is activity on arrow. This is activity on node. So අපිට ඕන නම් කියන්න මේ දෙකම ඉවරුනහම නැත්නම් මේ දෙක එකට මේවා කරලා දාන්න පුළුවන්. මෙයා මෙතනට කනෙක්ට් කරලා දැම්ම නම් හරි. So that is our project end. Right? That is our project end. So that is called activity on arrow. Activity on arrow. Okay. And these are the durations. These are the durations. Okay. Right. Now let's see how to calculate the critical path. Critical path means, or the critical path means the critical path of the critical activities. So what are the critical activities? Critical activities means if you delay that activity or task, it delay the project. Right? If a task delay the project, delay in task, delay the project deadline, it's a critical activity. Because some tasks you can delay without affecting the project deadline. Okay. Some tasks, if you delay the task, you delay the project deadline. So therefore, critical path means set of tasks, okay, or path that connect those critical activities. So how to find out the critical path? So if you use activity on arrow, we can do it using earlier start, late start approach, ESLS approach. Okay. So we do it in two steps. One is called forward passing, where we fill earlier start dates. Okay. So after that, we do the backward passing, where we fill the late start dates. Okay. Earliest start date means the earliest date we can start that task. Okay. Earliest date we can start that task. Late start means the latest date. ඒක ලේට්ම කරලා ඒක පටන් ගන්න පුළුවන් දවස. Without affecting the deadline. Right? So our task is optimize. Okay. So you in the forwards passing, we keep filling the ES. In the backwards passing, we fill the LS. So then we can find the critical path and critical activities. Right. So let's start it. You can start it here because this particular task has no dependencies. So therefore, what is the earliest start for A activity? Either you can say 0 or you can say 1. එක 0 කියන්නත් පුළුවන් 1 කියන්නත් පුළුවන්. හරි. පළවෙනි දවසේ කියලා කියන්නත් පුළුවන් නැත්නම් පළවෙනි දවසට කලින් කියන්නත් පුළුවන්. ඒ කියන්නේ ඒ දවසේ පටන් ගන්නකොට කියන්නත් පුළුවන්. So therefore we will start with 0 or you can even start with 1. Okay. It's up to you. So then what is the earliest start for B and C? මේ මෙතන කියන්නේ B and C. මොකද මෙයා මෙතන තමයි task එක තියෙන්නේ. These are the tasks. Because B and C both depends on A, earliest start for B and C is what? Second day. Because this take 2 days. 0 plus 2. So, okay, now I keep filling the earliest start. Okay. Then what is the earliest start for D? Because D depends on B and B take 3 days. If B take 3 days and earliest start for B is 2, then 2 plus 3 is 5. Similarly, what is the earliest start for task E? Because C take 2 days, earliest start is 2, maybe 2 කියන එක මේ දෙන්නටම පොදුයි. 2 plus 2 is 4. Okay, 2 plus 2 is 4. So then what about this one? earliest start for D is day 5. This take 1 day. So therefore earliest start for F is day 6. Okay, day 6. So then earliest start for F is 6 day and it takes 3 days. Assume that there's another task. What is the earliest start for that task? But there's no task like that. But assume that will be 6 plus 3, 9. Okay. Now we have done this part. Now we can do this path as well. Because earliest start for both B and C is 2. And this take 2. Therefore, earliest start for E is 4. And if there's another task after this task, but we don't have, but assume. So then the earliest start for that particular task is 4 plus 1, 5. 4 plus 5, 1. 4 plus 1, 5. And now we are done with the forward passing. In the forward passing, we have found the earliest start for each and every task. For example, for D task, earliest start is day 5. For E task, earliest start is day 4. For both B and C, earliest start is day 2. And for A, earliest start is 0 because A has no dependencies. Okay.
Excuse me, sir.
Yes.
So you told now that instead of 0, we can take 1 also.
Yeah.
Then that values will change, no? Other
Yeah,
values.
that values will be at 1 plus the given values. So your 2
Then
become
both the
3.
ways.
Sorry?
Then if we do both the ways, are these correct?
No, you can do whatever the way you want.
Okay.
Because it's a relative concept, right? Your project deadline depends on your starting date. Okay? Because this is not absolute values, right? This is not, we are saying that we start January 1st. So from that starting date, we move forward. Okay? From that particular, that starting date can be January 1st or January 10th or January 20th, 12th or whatever. Right. So now we can do the backward passing. In backward passing, we are going to fill the LS, that is latest start date. Latest start date. So there you need to start with the bigger value of these. If you have multiple endpoints, more than one endpoints, you need to look at what is the bigger value. And that value you need to copy there in both the places. එක තැනක නෙමෙයි තැන් දෙකේම ඒක තමයි copy කරන්න. So that is the latest start. If there's another task after this. If there's another task after this. Okay. So you copy that value, bigger of these two values, right? Bigger. That is your starting point because now we are going to come backward this way as well as this way. Right. So now this is the latest start if there's another task after F. So therefore, what is this value? This is the earliest. So that latest start for F is 9 minus 3, which is 6. Right? Because we have only one dependence. We have a dependence දෙකක් තියෙනවා තමයි වැඩි කචල් වෙන්නේ. Okay. So then you can keep coming backward. Here it is 6 minus 1, 5.
Excuse me, sir.
Yes.
How did we take that as 9?
We take the bigger of these two. So we have come to two ends. Out of those two ends, the bigger value is copied.
Okay.
Okay. Right. So now we have come to this point backward. So similarly from this way also we can come to this point. 9 minus 1 is 8. 9 minus 1 is 8. But here you need to be careful because we have sort of a it's a junction. Now if you go do the reverse from this part, it is 5 minus 3, which is 2. If you come from this way, 8 minus 2 is 6. Now out of these, you need to take the smaller value. In the reverse process, you need to take the smaller value. In the forward process, if you have something like that, you need to take the bigger value. අපිට එහෙම එකක් වුණේ නැහැ තාම. But forward pass, you take the bigger value. backward pass, you take the smaller value. Here the smaller value is 2, so therefore we take 2. So from here it is 2, from here it is 6. So smaller value is 2, therefore it is 2. Okay. And then of course this single path 2 minus 2 is 0. Always if you start 0, you must end up with 0. Otherwise you have made a mistake. Right. Now how do you find the critical path? Critical path is where these values are the same. Right? Values are the same, and not only that, when you add this value to this or this, you must get this value. 0 plus 2 is 2, 2 plus 3 is 5, 5 plus 1 is 6, 6 plus 3 is 9. So therefore, this is the critical path. Right? This is the critical path. So this is now your project will take 9 days. Right? And if you delay at least one of these tasks, for say this task is delayed by 1 day, then that means your project is delayed by 1 day. That means you need 10 days. Okay, but this task we can delay because the latest start is 4. Sorry, earlier start is 4, later start is 8. Late start is 8. So that means if you delay this by 1 day, say rather than the 4th day, you start in the 5th day. So then this will be ended in 10th day, but it doesn't matter because then it will ended in 6th day. But it doesn't matter because this task ends in 9th day. So therefore, yes, when you delay this by 1 day, you delay this task by 1 day. When you delay this by 1 day, you delay this task by 1 day, but it doesn't affect your project deadline because project deadline is 9th because this path has bigger, longer period. But here, if you delay a task, definitely your project deadline is extended, but not here. So actually, we have a 4 days even we can go up to 4 days. Because that is why earlier start is 4th day, late start is 8th day. But if you delay it more than 8, then your project deadline is extended. But here you can see the slack code, that value is always 0. That is why this is the critical path. Okay, critical path. Okay. So critical path is A, B, D, E, F, and the timeline is project minimum time is 9 days. But this task, you can even go up to 4 days of a delay. This task, again 4 days of a delay, but not both. One of those, maybe 2 days here, 2 days here. Still, you can deliver the project within 9 days. But if any of the task is delayed here, that will affect your project deadline because this is your critical path. Okay. And so this is another example. So do this as exercise. Right, it's a complex example. So you can start somewhere. You can see no dependencies for A and B. So you can start this as C. So then make Purudram high current, right? So 0 means this is 10. I'm just writing the earlier start. So this is 14. Now we have two possibilities. If you come from this way, 10 plus 2 is 12. If you look at this dependency, because D depends on B, so then 14 plus 5 is 19. So when you we are going through the forward pass, you need to take the bigger value. 14 plus 5 is 19. 10 plus, sorry, this is 10 plus, sorry, not 10 plus 2, 10 plus 11, sorry. You are supposed to get these values, not these values. These are the task numbers. Right. So from this path, it is 10 plus 11, 21. From this side, 14 plus 5, 19. So out of those two, the bigger value is 21. So therefore, you need to take 21. Right. So then this one is one line. 21 plus 8 is 29. And this one, we have to look at two paths. 21 plus 12. 21 plus 12 is 33. From this side, 14 plus 15, that is 29. The bigger value is 33. So therefore it is 33. 33. Then this one we can find because we have these two values. 29 plus 1 is 30. 33 plus, sorry, 29 plus 16, sorry. 29 plus 16, that is 29 plus 16, 5, 45. From this side, 33 plus 10 is 43. Bigger value is 45. And bigger value is 45. From this way, we have this path and this path. 33 plus 6 is 39. 14 plus 20 is 34. 39 is the bigger. Right, so now we can fill the last one. From this path, 45 plus 9 is 54. From this part, 33 plus 21 is 54. 39 plus 12 is 49, 51. So bigger value is 54. So that is our earliest start dates. Okay, earliest start date for these tasks. For this task 10, for this task, sorry, for I task 29, for G task 21, and so on. Okay. 10, 14, 21, 29, 33, 45, 39, and 54. Correct? Right, so now we are done with forward passing. Now we can do the backward passing. So now we copy the biggest value. What is the biggest value? 54. Biggest value is 54. So you just draw it. That is the late start. Okay. Then you do the reverse process. Backward passing. 54 minus 9, 45. Okay. Then 54 minus 12, 54 minus 12, 42. Okay. So then we can even find this one because just one path. 45 minus 16. 39. 39. Sorry, 29. 29. Okay. Right. So then what about this? So here we have three paths. Path තුනකින් දැන් calculate කරනවා. 45 minus 10 is 35. 54 minus 21 is 54 minus 21 is 4 minus 1 is 3. 33. This side 33. Then 42 minus 6. 42 minus 6. That is 36. So here in the backward pass, you need to take the smaller value. Forward pass, we took the bigger value. Backward pass, you need to take the smallest value. Smallest is 33. So therefore, this is 33. So therefore, this must be 33. Okay, so because this is 33. Now we can calculate this value. 29 minus 8, 21. 21. 33 minus 12. 33 minus 12. Again 21. Again 21. So therefore, anyway, it's 21. Okay. Now we can calculate this value because this is 21. 21 minus 11 is 10. Now we need to calculate this one. We need to consider this, and this. 42 minus 20 is 22. 33 minus 15, 18. 21 minus 5, 16. Okay, 16. So the smallest is 16. 10 minus 10 is 0. 16 minus 14 is 2. The smallest is 0. So now we have done the backward passing. Right? Backward passing. Is it clear? Right? 54, 45, 42, 29, 33, 21, 16, 10, and 0. Okay. Right. Right. So now we have done the forward passing and backward passing. Now our task is find the critical path and critical activities. So remember, look at those values having the same value. These are different. But just because you have the same value, you can't say this is our critical path. Now you need to check 0 plus 10 is 10. Yes, this is in the critical path. 10 plus 11 is 21. Yes. 21 plus 8, 29. Yes. 29 plus 16, 45. Yes. 40 plus 5 plus 9, 54. Yes. This is our ending point. තව තියෙනවා මේකේ නේද? මේ තියෙන්නේ. Because this is to this, මෙයාට මෙයා කියන්නේ මේක. But 21 plus 12, 33. නේද? 21යි 3යි 21යි 12යි කියද? 33. 2 plus 1 is 3. 2 plus එතන මෙහෙම එන්න පුළුවන්. So then 33 plus 21, 3 plus 1 is 4. 3 plus can make a critical path. So we have two critical paths, this path as well as this path. Okay. Right. So that there's a possibility of multiple critical paths. So therefore we have two critical paths, this path as well as this path. සමහරවිට මෙහෙම තිබුණාට සමහරවිට මේක මෙයාට මෙයා එකතු කරා මෙයා එන්නේ නැහැ. එතකොට මෙයා critical path එකට එන්නේ නැහැ. හරි? එහෙමත් වෙනවා සමහරවිට. මෙතන critical path දෙකක්ම ආවා. හරි. So therefore critical activities are A, C, G, I, sorry, not J, M, and K. Non-critical activities are B, D, E, F, L, N, and even J. So these activities can be delayed. Okay, delayed, but not these activities because these are in the critical path. Okay, this is also in critical path. So that is how you find the critical path and critical activities using the forward passing, backward passing. Forward passing at the bigger value, backward passing when there are multiple competing values at make the smaller value as the value. Okay, okay. Is it clear? So therefore, we can finish this project minimum of 54 days. But we can do it within 54 days if these critical activities are not delayed. Activities in the critical path are not delayed. If one day is delayed, then this deadline is delayed. Critical activities. But these activities like this, because this activity can be even delayed for 2 days. මෙයාව දවස් දෙකක් delay කරන්න පුළුවන්. Because earlier start is 14, late start is 16. So that delay will not cause a delay for final deadline. Okay, final deadline. So this one also 2 days. Sorry, 3 days. මෙයා දවස් දෙකක් delay කරන්න පුළුවන්. මෙයාව දවස් 3ක් delay කරන්න පුළුවන්. මොකද මෙයාගේ 39 41 ඇති. මොකද මේ 42 වෙනි දවසේ පටන් ගත්තත් 54 වෙනි දවස් වෙදී ඉවර වෙනවා. මොකද අනිත් මේ පැත්තෙන් එන කොහොමද දවස් 54ක් යනවා. Okay? Right. So this is the activity on arrow approach. Okay. Is it clear? Is it clear? Okay. මොකද මේ question එකක් දුන්නොත් ඔය වගේම ඔච්චර කම්ප්ලෙක්ස් කරලා දෙන්නේ නැහැ. මම ටිකක් කම්ප්ලෙක්ස් එකක් හැදුවේ එකපාර. වැඩේ නොදැන කරන්න බෑ. ළඟදී දීලත් නෑ හැබැයි. ඉස්සර නිතර දෙනවා. And all these are in your note. Right. So one of the drawback of this approach is one is we have only earlier start and late start. But in other approach, we have earlier start, late start, earliest finish, late finish, four data. Here we have only two data in activity on arrow. Other thing is, in some kind of a dependencies, when we have very complex dependencies, you can't just go like this. මේ වගේ එකපාර අඳින්න බැරි වෙනවා. So in that kind of situation, you have no other option but to introduce dummy activities. There is another drawback of this approach, but doable. But you must know how to add dummy activities, right? So though this look very complicated dependencies, set of dependencies, actually we can draw this without dummy activities. Right? මේක කිසි කරදරයක් නැතුව dummy activities නැතුව කරා. හැබැයි සමහර චූට් simple දේවල් තියෙනවා dummy activities නැතුව කරන්න බෑ. Okay? So this is an example like that. Okay? For example, let's see whether we can show these dependencies. අපි diagram එකක් අඳින්න පුළුවන්ද බලමු. So we can start K without any issue. At any time we can start K. Okay. We can start L because no predecessors, no dependencies. We can start M. So in order to start N, both K and L must be done. So if both K and L must be done to do N, remember these are the tasks. These are just numbers. 1, 2, 3, 4. For both K and L, after finishing both K and L only, we can start N. So දෙකට කරන්න එකම වැඩේ මොකද්ද? මේ දෙක එකක් කරනවා. ඒ කියන්නේ අපි කලින් කරේ. For example, if in order to do G, we need both C and D done. Both C and D done. එතකොට මොකද කරේ? C D එකට එකතු කරලා එතනින් තමයි G පටන්. H කරන්නත් එහෙම වුණා. C and D done. එතකොට C and D දෙක එකට එකතු කරලා එතනින් H පටන් ගන්නවා. So let's do the same thing. So let's use the same approach. Right. So therefore, in order to start N, both K and L must be done. So therefore, let's combine this. මේ දෙන්නා මෙහෙම connect කරමු. KL. Okay. When both K and L is done, we can start N. ඔතනින් අපිට දැන් N යන්න පුළුවන්. Okay. So then what about this? In order to start O, both M and L must be done. ඒ කියන්නේ M සහ L දෙන්න වෙන්න ඕන. Now we are in trouble because now L and K is already combined. දැන් M and L සම්බන්ධ වෙනකොට මෙයාව ගිහලා මෙතන දාන්න පුළුවන්ද? මෙහෙම දැම්මොත් මොකද වෙන්නේ? මෙහෙම දාලා ඉවරලා මෙතනින් O ඇන්දොත් වෙන්නේ. So that means in order to do N, you need K, L and M. නෑ M ඕනේ නෑනේ. Right? For N, you need only K, L. And also, in order to do O, this says you need K, L and M. Actually, you need only M and N. So therefore, this doesn't work. Right? This doesn't work. Maybe they make on the because you can't have L two times. L දෙපාරක් අදින්නත් බෑ. හරි. මෙහෙම අරගන්න බෑ. So now we can see when we have this kind of a dependencies, you can't draw simply because K and L determines N, M and L determines O. So when this kind of a situation, we need to introduce dummy activities. අපි මේ වගේ වෙලාවට ඇත්තට මෙතනින් කඩන එක තමයි කරන්නේ. හැබැයි ඒවා කරන්නේ dummy activities දාලා. හරි. Look at what I'm doing. Because L is common. L is common. So therefore we take L somewhere here. And then we draw a dummy activity. So then K and L, this is a dummy activity. This is an activity with 0 time. එතකොට මෙයා depends වෙනවානේ මෙයා මත ඒක හන්ද n depends on k and l. This is a 0 duration dummy activity. Okay, so similarly you take k here and dummy activity again. Then this dummy activity and m is done. We do O. And this is a 0 duration activity. So therefore it's like when we do M and L, we can do O. Okay, we can do O. Is it clear? Okay. Right. So then this is our last make a dummy. Then we can connect these two. Make a connect camera. That is your N. That is your N. Okay. So you need to introduce these two dummy activities. So now your N depends on K and L. And your O depends on M and L because this is a dummy activity. And now we can proceed with forward passing and backward passing. You come to this point, this point, this point, this point, this point. හරි. මෙතනින් මෙයාගෙනුත් බලන්න ඕනේ, මෙයාගෙනුත් බලන්න ඕනේ. හැබැයි බලනකොට මෙයාගේ 0 කියලා හිතාගෙන කරන්න. මෙයාගේ 0 task එකක් කියලා හිතාගෙන කරන්න. So that is how you overcome that problem. So therefore that problem can be solved but with the help of dummy activities. Okay, with the help of dummy activities. For example, let's assume the time durations also. That means time duration udara karamu onna. Say this take, let's assume this take 2 days. This take 3 days. This take 2 days. This take 5 days. This take 1 days. So then we'll start with 0. K take 2 days. So this is 2. L take 3 days. Right? And M take 2 days. No dependencies. Now, okay, එහෙම දාන්න බෑ නම් මෙතනින් ලියමු. K take right. Let's draw it properly. K take 2 days. මෙහෙම ලියන්න ඕනේ ඉස්සෙල්ලා හරි. K take 2 days. L take 3 days. M take 2 days. N take 5 days. හරියට කරමු. And O take 1 days. Now this is 0. This is 3. Okay, this is 3 because only one part. And this and here we have now 2 parts. From this part 2. From this part 3 because here 3 plus 0. This is 3. From here it is 2. We remember we need to take the bigger value. Forward passing. Therefore we need to take it as 3. මෙයා දැක්ක 3 කියලා ගන්නවා. Right? And here also this part 0 plus 2 is 2. This part 3 plus 0. මෙයා 0 කියලා ගන්න. 3 plus 0 is 3. So you need to take the bigger value which is 3. And from this part 3 plus 5 is 8. 3 plus 1 is 4. The bigger value is 8. Right? 8. Now the forward passing is done. Now backward passing. මෙයානේ අපේ end එක. So we copy that. And then back reverse. 8 minus 5 is 3. 8 minus 0, sorry, 8 minus 8 minus 1. Right? 8 minus 1 is 7. So then 3 minus 0 is 3. Let's use a different color. 3 minus 0 is 3. 7 minus 0 is 7. So you need to take the smaller value, which is 3. Okay. So then 3 minus 2 is 1. 3 minus 3 is 0. 7 minus 2 is 5. Smaller value is 0. So this is our final diagram. හැමතිස්සෙම මේ සමාන වෙන එකක් එනවා. So you can see 0, 0, 3, 3, 8, 8. And 0 plus 2 is 3, 3 plus 5 is 8. So therefore this is the critical part. Right. So here earlier start is third day. Later start is 7th. ඒ කියන්නේ මෙයාව දවස් 4ක් delay කරන්න පුළුවන් මෙයාව. මේ deadline එක වයින් නැතුව. But these tasks you can't delay. What are these tasks? K and N. K are in critical activities.
So I think it's not K, it's L.
Sorry?
I think it's L, not K.
Yes. 0 plus 2 is not 3, right? Yes. That's a good thing. Right. Yes. This is not the critical part. Because 0 plus 2 is not 3. 0 plus 2 is 2. But this one is correct. 0 plus 3 is 3. 3 plus 0 is 3. Yes. So therefore, critical path is actually this path. This path. Right? This path. So therefore, that is why I told you, just because you have same values, don't connect. Because 0 plus 2 is not 3. But here 0 plus 3 is 3. 3 plus 0 is 3. Because these are dummy activities. Dummy activities are 0. So why we introduce dummy activities? Otherwise, you can't show these two dependencies correctly. In order to show these two dependencies, we had to add these two dummy activities. Okay. Right. Right. So that is activity on arrow, because activity is on the arrow. Okay. And here we use few words. පොඩි වචන දෙකක් කතා කරනවා එතන. ඒ තමයි මොනවාද? Free slack and total slack. Right. So the synonym for slack is float. So that means whenever you see the word slack, you can replace it with float. So that means free slack or free float, total slack or total float. Okay. So what is mean by free slack or free float? Then what is mean by total slack or total float? Okay. Right. So what is free slack or free float? That is the amount of time an activity can be delayed without delaying the early start of any immediate following activity. So it is something like that. For example, right. For example, now let's find the critical part. Right. For example, now these are critical activities. We can't do anything for these tasks. Right? We can't do anything for these tasks. Right? So that means the free slack or the free float is 0 for task A, C, G, I, and M. But if you look at other tasks, for example, if you take this particular task, B, the latest start is 14, earlier start is 14, latest can late magalla, parakku magalla, start is 16 for these three tasks. So therefore, if I delay this task by 1 day, right? So that will delay this task by 1 day, right? And that will delay this task by 1 day, this task by 1 day. Okay, but that won't delay the deadline because these are not in the critical path. Okay. So therefore, if a task is not in a critical path, delaying of a task may not delay the final deadline, but it will delay the next task. It will delay the next task. Okay. So therefore, if a task is not in a critical path, delaying of a task may not delay the final deadline as well as, but it will delay the next task. Right. So therefore, if a task is not in a critical path, delaying of a task may not delay the final deadline as well as, but it will delay the next task. right? It will delay the next task, but not the final task. But if you delay so much, yes, it will delay the final task. So therefore, free slack or the free float means how much you can delay your task without delaying your immediate task. That is free slack. Okay. How much you can delay your task without delaying the final deadline is called total slack or total float. So those are two concepts. Sometimes your task delay will delay your immediate task, but it won't delay your final deadline. But if it is in a critical path, definitely a single day of a delay in a task will affect all the next task in the critical path as well as the total deadline will be delayed. Okay, so
Sir,
that
I think it won't delay the immediate task also.
which one?
Third one,
What is the third one?
it's not a critical path, but if we
Which
take
one?
the latest one,
Third one
third
is
one,
this one.
yes.
So this will delay. So this is we need 14 days. Earliest start is 14. So this take 5 days. 14 plus 5 is 21. Okay. So
No,
therefore, if you
14
delay this
plus
start
5
by
is
1 day, this
19,
will
I
be
guess.
delayed by 1 day, right? Isn't that? Because you can't start these three tasks without finishing this task. If you delay this task by 1 day, all these tasks are also delayed.
But if we take the latest path, and if we added with 5, it will be 21, right?
No. So this is the earliest start. Okay. So if earliest start is say this take 14 days. So if you delay this by 1 day, so it delay this one by 1 day because you can't start this task without finishing this task. How can you start without delaying these tasks when this is delayed? Because you can't start these tasks until this is finished. So when you delay this, the finish get delayed. Is it not clear? Because these three
Yes,
tasks
sir.
depends on this. You can see these three tasks depends on this. So if B is delayed by single day, these three tasks get delayed, but it won't affect your final deadline. That is why we say that is the free slot, free slack. Okay. But there are situations,
Understood, sir.
yeah, but there are situations, for example, if you delay this task, right, it won't affect this task. Why? Say, this is from this side, 10 plus 11 is 21. 21. From this side, 14 plus 5 is 19. Now, if this task is delayed by 1 day, right, it won't delay this task. Why? Anyway, it need to wait until 21st day. Now, though you finish it in 19, it doesn't mean that we can start this because we need to wait until this is. So therefore, delay of this task will not delay this task. But if you delay it more than 3 days, yes. If you delay it 1 day, this is finished in 20th day. Still, this guy is waiting for this to finish. 2 day delay, now still okay. But 3 days delay, that will delay this task by 1 day. Not 3 days, 1 day. So therefore, when this is delayed by 3 days, this is delayed by only 1 day. When this is delayed by 2 days, no delay for this task. Right? Is it clear? Right? So therefore, free slack is one thing, total slack is another thing. Because sometimes when you delay a task, it delay your immediate task, but not the final task or the final deadline. Right? Sometimes delaying of a task by a particular date, say it won't affect your next task as well as final deadline. Okay. So these are two different concepts. Free slack, total slack. Okay. Right. So that is activity on arrow diagram. So activity on arrow diagrams are easy, but sometimes you may need to add dummy activities. And in activity on arrow diagram, we only concentrate on early start, late start. Okay, early start, late start. So the second approach is, so I have given you so many examples. පාඩ මේ උත්තර ඩබල් චෙක් කරගන්න ඕන chat GPT දාන උත්තර ටික දෙයි. හරි? chat GPT දාම උත්තර ටික දෙයි. හරි? Right. So the next one is activity on node. Another name for that is precedence diagramming. නම් ටික පැටලෙනවා හරියට. හරි? activity on node. කලින් activity එක තියෙන arrow එකේ. හරි? node වල තියෙන නිකන් නම්බර ටිකක්. So here now activities are on the node. And there are two advantages here in activity on node or precedence diagramming method. One is we have 4 values now. Not only early start, early finish. We have late start and late finish as well. So earlier we had only, earlier we had only earlier start and late start. Early start, late start. Okay. Early start, late start. Early start, late start. Now we are going to have early start, late start. Have a pennana තැන් දෙක මාරු කරනවා මෙතන. This is early start, this is late start. Then early finish, late finish. ඒක ඉතින් ඔය පාවිච්චි කරන notation එක ගන්නවා. Okay. And these are your activities now. These are your activities. So therefore, now we have more information. At the same time, now you can represent any dependency without dummy activities. Then අපිට dummy activities ඕන වෙන්නේ නැහැ. Okay. Right. Again, this is not rocket science. Only thing is we have more data, but the theory is the same. You just go do the forward parsing and backward parsing. Actually, for me, this is the easy approach because you don't need dummy activities and so on. Okay. Right. Again, how do you start it? So this means your B depends on A, C depends on A, D depends on A, E depends on A, and F depends on both C and D. So very lazy. And G depends on B and F, H depends on G and E. So again, you do the forward passing. You can start with earlier start. Okay. හැබැයි දැන් fill කරන් යන්නේ earlier start එකෙන් earliest finish එක. මොකද මෙතන තමයි task එක තියෙන්නේ. Okay. So you can again start with something like 0. Okay, අපි මම fill කරගෙන යන්න. Say you can start with 0 because no dependency for a task. This is now task. So it take 2 days. This is our duration. Duration ටික දාගෙන ගිහලා පටන් ගන්න. So therefore earliest finish for A is 2. Because these tasks depends on A only. The earliest start for B, C, D and E is 2 because that is the earliest finish for A. Just copy it. Then of course earliest finish is 15 plus 2. 17. 17. 10 plus 2, 12. 13 plus 2, 15. 18 plus 2, 20. Okay.
Excuse me, sir.
Sorry?
How did you get that 2? Is it from the duration?
Yeah, duration, because it take 2 days to
Okay.
do. Right. So then this earliest finish is the earliest start for this. But it's not only this. You need to look at this and this. So therefore, let's first finish this one. Now this one depends on both tasks, C and D. Earliest finish for C is 12. Earliest finish for D is 15. So you need to finish both to start this. So therefore, earliest start for F is 15 because we need both finish, right? Bigger value. Then 15 plus 15, earliest finish is 30. Now G depends on both B and F. Earliest finish for B is 17. Earliest finish for F is 30. So we need both finish. So therefore take the bigger value, 30. And now 30 plus 10 is 40 is the earliest finish. This depends on this and this. earliest finish for this is 20, this 40. We need both finish. So therefore, earliest start is 40. And 40 plus 5 is 45. For me, actually, this is the easy one. Okay. Less ambiguous. Now you can do the backward passing. So how do you do the backward passing? Because we are going to have late start and late finish. So you just copy earliest finish as late finish because we don't want to delay our project. Total duration. So therefore you just copy earliest finish as the late finish. Why? We don't want to, we want the optimum solution. So now you do the backward passing. 45 minus 5 is 40. Okay. So then this late start is the late finish for this part and also the late finish for this part, right? Because late finish for this one is the late start for this one, right? So therefore, this is 40. So therefore, late finish for this one is 40. And late finish for this one is also 40. Because we have late finish කරන්න 40 වල නැත්නම් මෙයා delay වෙනවා. Right? Then 40 minus 10 is 30. And here 40 minus 18 is 22. Right. But what about this? From this path, right? From this part, this is the late start. And what we are looking for is the late finish. This is 30. So therefore this must be 30. From here, this is the late start. So that must be the late finish, 30. Okay. So then 30 minus 15 is 50. Now this one is, no, this one is also fine. Right? If this is 15, this is 15. If this is 15, this is 50. Then 15 minus 10 is 5. 15 minus 13 is 2. 13 minus 15 is 50. මෙන්න මෙහෙම අපිට ඔන්න පළවෙනි වතාවට හම්බුනේ. හරි. So 15 from this path, remember late finish is the late start is the late finish of this. So therefore from this path it is 15. From this path it is 5. From this path it is 2. From this path it is 22. Right? You need to take the smallest value. What is the smallest value? 2. So therefore the late finish for this one without affecting the project is second day. You can't late it for 22nd day or 15th day because then it will affect this path. So therefore your latest finish date is, earliest finish date is 2, latest finish date is also 2 because this is the smallest of this. Out of these, smallest value is 2, right? So then 2 minus 2, latest start is 0, right? Now you can calculate the slack values. That is latest start minus earliest start. Late finish minus earliest finish. 5 minus 2, 3. 15 minus 12, 3. මේ දෙක අනිවාර්යෙන් සමාන වෙනවා. හරි? මොකද මේ task duration එක වෙනස් වෙන්නේ නැහැ. 13 minus 17. 13. 15 minus 2, 13. This is 0, this is 0. This is 20, this is 20. This is 0, this is 0. This is 0, this is 0. This is 0, this is 0. Now again we got slack 0 are the activity critical activities. So that is this one. Slack 0 is here. Slack 0 is here. Slack 0 is here. Slack 0 is here. ඒක එකතු කරලා බලන්න දෙයක්වත් නැහැ because this is 0 plus 2 is 2, right? 2 plus a බලන්න දෙයක් නැහැ. So therefore this is your critical part. And these are the critical activities A, D, F, G, and H. Okay. So these are the critical activities. So if you delay any of these activities by a single day, all the preceding activities will be delayed as well as the deadline will be delayed. But this task you can delay because we have a slack of 20 days. මෙයා earliest පටන් ගන්න ඕන දෙවෙනි දවසේ. ඔයාට ඕන 20 වෙනි දවසේ පටන් ගත්තත් කමක් නැහැ. ඒත් මේ ටාස්ක් එක ඩිලේ වෙන්නේ නැහැ සහ ප්‍රොජෙක්ට් එකේ ඩෙඩ්ලයින් ඩිලේ වෙන්නේ නැහැ. And so this one we can delay for 3 days. 3 days without delaying the project deadline. Okay, project deadline. But if you delay this by single day, it will delay this one. මෙයා delay කරොත් මොකද වෙන්නේ අපිට? 15. Here also 15, right? Yeah, if you delay this one, it's going to delay this one anyway. Right? එතකොට මෙයා critical path එක යන්න ඕනේ එහෙනම්. Right. 15, 15, 15, 15. What happens if you delay this one?
So there is early finish. You are looking at the latest finish.
Yes. So this is earliest finish 12. Earliest finish is 15. So therefore earliest finish can be even, but late finish also we need to consider. Yeah. Earliest finish is 12. The late finish is 15. So therefore the gap is 3 days. So if you delay it by 3 days, it won't affect because anyway you can't start this without 15 days because earliest finish for this task is 15 years. So we need to look at those two values, not these two values. So therefore we can delay this by 2 days, even 3 days without affecting this task as well as without affecting your project deadline. Okay, because we can go up to 15 days for late finish. Okay, so likewise you must be able to interpret this diagram and take decisions. Okay, right. So this is more comprehensive because we have earliest start, earliest finish, late start, late finish, everything, and also we don't need to add dummy activities. Project dependencies can be easily mentioned, but in the exams, in second paper questions, sometimes examiner tell you exactly use this approach. So then don't use anything other than the specified approach. Okay. Right. So any questions? Any questions? මොකද ටිකක් පහළට ගියොත් ඒ අන්තිම අවුරුදු තුනේ අහලා නැහැ එහෙම අමාරු questions making. හරි? That means the last 3 years actually exam is easy. හැබැයි එකපාරට exam එක tough වෙනවා. එහෙම තමයි pattern එක යන්නේ. Almost impossible papers දෙනවා. So let's look at the last year paper. ඔය ඔක්කොම note එකේ තියෙනවා හැබැයි යා. මොන note එකේ තියෙන්නේ? මේකේ චූටි ගණන් ටිකක් දීලා තියෙනවා. මේක ඇත්තටම nothing. ඊට කලින් paper පළවෙනි අවුරුදු පහුගිය අවුරුදු තුනම වගේ ලේසි. හැබැයි ඉතින් වැඩේ තියෙන්නේ එකපාරට අමාරු කරන ඊට ඕවා. මේවා අර ඒ වගේ ඒවා අඳින්න දීලම නැහැ. තියරි විතරයි අහලා තියෙන පහුගිය අවුරුදු 3-4. ඒකන්ද මේක ඕනරෙඩි බය වෙන්නත් එපා. මේ නිකන් කැල්කියුලේෂන් තියලා තියෙනවා. ඔය වගේ ගණන් දීලම නැහැ දැන් අවුරුදු 5ක විතර මම හිතන්නේ. 2021. But all these things are in your syllabus and UCSC note. හරි? දැන් ලොකු ප්‍රශ්න දීලා නැහැ පොඩි පොඩි ප්‍රශ්න වලින් තමයි දීලා තියෙන්නේ. හැබැයි ඒක පාට දෙන්න පුළුවන් මේවත් අර ඒ වගේ question නෙමෙයි forward passing backward passing කරන්න දෙයක්. ඔය ටික පහළට ගිය ගමන් ඔය වගේ ඒවා හම්බ වෙනවා. සිලබස් එක වෙනස් වෙලත් නැහැ හැබැයි. No change to syllabus. මේක answer sheet එක නෙමෙයිනේ. That is MCQ paper. So therefore better be prepared. Better be prepared. Okay. ඒක answer sheet එක නේද? Right. So any questions on that? Now you can go through the UCSC note because UCSC note refer to both these approaches. Okay, both these approaches. So this is activity on narrow. Okay, and this is activity on node. Okay, late start, late finish, free slack කොහොමද I can interpret කරන්නේ. Okay, and so on. Okay. Right. So let me quickly go through the UCSC note. So now you can understand this. Milestone is, now remember I did explain you the Gantt chart. Okay. So the Gantt chart is not this. This is we used to find the critical path, critical activities during the planning. So once you identify these, we can prepare the schedule. So schedule is represented by Gantt chart. Right? Gantt chart. So Gantt chart is uh, something like this. Okay. So there are project management software. You can say online project. If you have MS project, that is ideal. Have MS project then හොයාගන්න අමාරුයි. Say online project management free ඒවයි Gantt chart එක ඇඳෙනවා. Okay. දෙකක් විතර try කරන්න. Say get started. බලන්න watch video එකෙත් බලන්න ඕන. Sign in using this. So let's see whether this has a Gantt chart. Why it's taking so much of time? Right. Tasks. So how can I start? New project. So let's use a project template is available. No templates available. This is let's say this one. Use this template. Right. So here you can see there are some tasks. Okay, preliminary activities. So this is sort of a high level activity. Okay, high level activity. So where is the Gantt chart? Tasks, issues. These are the timesheets. Where is the Gantt chart? It doesn't look very good one, right? Not very useful one. So this is my task breakdown. Okay, let's use a different tool. That is not a very user-friendly tool. Project. It's a Gantt chart tool. Free, online. That is Gantt chart in Excel. This one looks better, easier. Okay, so this is like this is more Gantt chart. Okay, so you can see we can have tasks. Right, say this is say my project. Let's say this is analysis. Right, so then I can say gather, analyze. This is like a more waterfall, model, document. So then we can add another task, say design, right? Add, say design task, design. You can set what is the starting date, ending date, duration, right? අපි ආ මෙතෙන් ඇදලා දාමු. එතකොට date වෙනස් කරගන්න ඕනේ. Okay. Say design task. Say end date is, say duration is, say 4 days. එක දෙයක් දැන් drag වුණා. දැන් මම dependency පෙන්වන්න පුළුවන්. මෙයා depends වෙනවා මෙයා මත කියලා. හරි. This is a milestone. Okay, this is a milestone. So this depends on, yeah, dependency. So this depends on analysis tasks, right? Add analysis tasks. Okay. නැත්තම් අපි කිව්වේ මොකක්ද ඒකට කිව්වේ? Analyze or subtask called document. Okay. Document කියන subtask එකේ මත depends වෙන offset එකක් කියන්නේ එතන පොඩි gap එකක් තියන්න ඕන. හරි. The type is finish to start. This must be finished for this to start. Okay. Now you can see there's a dependency. Right. So likewise, then we can show how much the progress. අපි දැන් project එක යනවා කියලා. ඉතින් අපිට කියනවා මේක කොච්චරක් finished. For example, percentage progress එක තියෙන්නේ 180යි. So I can say it's 100% finish. Right, 100% finish. That is during the project controlling. Right, green. So maybe this is 70% finish. So likewise, you can see the progress also. Okay. And this is pretty much a milestone. Okay. So 0-day task. So we can mark it as a milestone. But कोई हरी ऐसी milestone किया. So milestones duration must be always 0. But where do you have edit as a milestone? Zoom it, zoom out. And also we can allocate resources. You can add resources separately, like software engineer 1, software engineer 2, software engineer 3. So that you should be add separately. So there should be somewhere to do that. Where is that? Yeah, resources. Making team member 1, team member 2. So we can assign resources to these tasks as well. Maybe I can assign team member 1 and team member 2 for this task. For this task, maybe team member 2 and 3 and so on. Then, right? So likewise, you need to check whether that resource is available. Sometimes we can say 50% working on this task, 50% working on this task. Then the same day we can allocate the same resource to 2 tasks and so on. Okay. So this is called a Gantt chart. This is not for calculating critical path and so on. This is after finding critical path and everything. This is the schedule. Right? This is the schedule. The project manager's task is check whether we are going on according to the schedule. Okay. Right. But the bad news is following this kind of a schedule is very difficult in software development. That is why in agile development, we do agile project management, where we do task in 3 weeks. මේ වගේ මාස ගණන් schedule කරන්නේ නැහැ ගොඩක් අය. ඒත් මාස ගණන් schedule කරන්නේ ගොඩක් අයට iterations. Right? Because that 3 weeks of agile schedule is very much casual schedule. Casual schedule based on our daily stand-up meetings and burn down charts and so on, rather than having a Gantt chart like this, because it's very difficult. Software development is very fussy, chaotic kind of a thing. Okay, sometimes a particular task can take 2 days, another task maybe you expected 2 days, but finish it in 1 day and so on. Okay, but anyway, this is the theory. Okay, this is the theory. Okay, right. So there are some more concepts mentioned there. Those things they check in the exam. So we discuss about the 3 point of estimation. Okay, optimistic, most likely, and pessimistic. Okay, and also we can. So these are the tasks and dependencies in a Gantt chart, and these are the milestones. So milestones are represented by sort of a diamond shapes. Okay, so I think that smart milestone is shown somewhere else. Yeah, this is a milestone. So those are the important like release dates and so on. Okay. So other thing is when you specify a milestone must comply with SMART criteria. What are the SMART criteria? It must be specific, because milestone must be specific. What you are supposed to deliver, right? Measurable, right? So that means we are supposed to deliver these 4 user stories. So that is our measurement to see whether we have achieved the milestone. Maybe no, we have only delivered 3. That is fine. So then still we can measure, right? 3 out of 4 we have delivered. Assignable. So we must be able to assign to someone, you are the responsible person for this milestone. You are the responsible person for this release. This is all about the milestones, okay? Realistic, obviously, right? Otherwise, we set up milestones, but we can't achieve those. And time frame, right? Time box. So milestones usually we don't drag it, right? Especially in agile. If you have milestone this Friday, we are supposed to release it. Maybe we have not achieved all 100%, but milestone is a milestone. Okay. So we call them SMART criteria of a milestone. Okay. Right. So these are milestones. Okay. These are milestones. Right. So we discussed about the slack or float. Okay. Free slack, total slack, or the free slot and the total slot float. Okay. Right. So මේවා අපි දැන් කතා කරලා තියෙන්නේ critical path. So free slack versus total slack, and also we did the forward passing and backward passing in both the approaches. Okay, both the approaches. So this is a very simple activity on a node diagram. Early start, early finish, late start, late finish. Right, so the next thing is, once you prepare this and find the critical path and the project duration, say our project duration is, after doing the calculation, the project duration according to critical path is say 20 days. So say there's a requirement from the customer or whatever, we want to finish it within 15 days. But according to the estimation, in even the critical path estimation, it takes 20 days. So if you want to shorten further, so that is called uh, shortening a project schedule. So there are some techniques for that. Okay. So they have mentioned 3 techniques to shorten your schedule. What are those? Shortening, crashing, and fast tracking. Shortening, crashing, and fast tracking. So what is mean by shortening? Okay, so that means by adding more resources, so somehow you reduce the duration of a critical task. See, critical task takes 5 days. So you somehow try to finish it less than 5 days, because the moment you reduce a time period of a critical task, you reduce the time period of the project. Okay, so that is called shortening. Okay, shortening, or you can change the scope. See, change the scope means maybe you can reduce the work. Some uh, functionality we are not going to deliver. Okay, so that is called shortening. Crashing means crashing activities by obtaining the greatest amount of schedule compression for the least increment cost. So that means again, add more resources to the most important tasks. So, but not usually by cutting down the scope. So these are pretty much the similar things. But in crashing, usually we cut down the time of the critical activities, uh, right? But fast tracking is different. So that means we try to do those tasks in parallel or overlapping. Maybe you assign same person for two tasks. So these things may not be practical, but sometimes it can be practical, right? Sometimes it can be practical. So the idea is to reduce the project duration. Reduce the project duration. But these things must be done to mainly to critical activities, because other activities maybe you make it shorten, but still your project duration won't be affected. Okay. Right. So the realities. Right. So we discussed about these 3-point estimates. So remember we have the optimistic time, most likely time, and the pessimistic time. So then how do you know their estimated duration? See, someone will say, okay, most likely it will take 10 days. Optimistically, it will take 8 days. Pessimistically, it will take 13 days. So then this is a common formula we use to calculate the time duration, because it is none of these three. Rather, you take optimistic time plus 4 times realistic time plus pessimistic time, then divide by 5, because we take 4, so divide by 6. So usually this is taken as your task duration, right? Optimistic time plus 4 times realistic time, that is most likely time, plus pessimistic time divided by 6. So why do you multiply it by 4? We give more weight for the realistic time, right? Realistic time we give more weight rather than just add these three and divide by 3. We give more weight to the realistic time. So then that time can be used as your time duration if you use PERT approach. Okay. Right. So then after the scheduling, project manager need to control it, because sometimes we are lagging behind the project. So then you need to take some control actions like assigning more resources. Maybe you need to cut down some functionalities. And if there are blockers, you need to remove those blockers so that project can proceed smoothly and so on. Okay. So that is controlling activities. Right. So that's it. Again, go through the UCSC note and start doing quizzes, sorry, exam questions for this subject as well. Right. So the Monday you have another session, right? 7 to 10. Monday, most probably we will be doing EAD paper, because I want to start EAD past papers as well. Okay. Right. We'll stop at this point, right? Thank you.